In this course, I will cover how to build full-stack web applications completely using AI. The first half of this course will cover coding basics and fundamentals just so that you understand how to generate AI code and debug at a high level. Then we'll take out the concepts that we've learned and build out a full-stack CRUD application that will serve as the foundation for any web application that you want to build in the future. This course is intended for complete beginners with no technical background, so that we'll cover everything you need for you to begin building apps completely with AI. And if you enjoyed this free course, make sure to check out our website at AI Code Pathways, where we help beginners learn AI skills and how to build completely with AI. Now, let's get started. One important concept here is that AI only empowers you. So contrary to what you've seen on the internet, you need some level of fundamentals or else you'll be prompting completely blind. So you can have the best prompts and cursor rules, but if you don't understand anything that's happening inside the outputs or where things are breaking or even where things are supposed to go, you won't get far. So you can think of this like cooking. If you have no cooking knowledge and AI provides a very complex recipe, you could manage to create a passable dish after a while, even though you don't know why you did any of the steps you did. So for example, like adding a reduction sauce or deglazing the pan. So for starters, the instructions may be a bit hard to follow in the first place, given that you have a lack of general knowledge to understand basic cooking lingo. And if you don't have the cooking fundamentals, you don't know why certain things are happening. This could be an issue later on if the flavor has too many hints of XYZ. You won't know which step in the recipe you need to fix. But if you do already have cooking fundamentals, then you'll be able to understand most steps at a high level that makes it actually easy to follow along the recipe since you have a baseline knowledge and you can understand the lingo. Then once you get complaints about certain flavors, you can slightly tweak the given recipe. And if anything does go wrong during cooking, like if the sauce is separating, you can recognize why this is happening and fix it immediately. So without fundamentals, you're essentially just blindly following steps without understanding why or how to fix things when they go wrong. So before we start throwing random stuff inside an AI prompt and praying, I'll cover the core concepts you need to understand the AI code at a basic level and also how to fix it at a high level. And thankfully, with the use of AI, we don't need months to learn any of this. I'll condense all of this background information we need within the first half of this course. And we can always ask AI whenever we have more questions, especially once we start building. Then from here, we'll do a full build of a CRUD full stack application that basically translates to the foundation of any SaaS you want to build, given that it has all the database functions of a full stack application, which you only need to learn once so that you can apply it to any SaaS you'll build moving forward. Now let's go over the best tech stack to use for building SaaS applications completely using AI. And just for your information, a tech stack is just all the technology used to build an application. So in our case, we'll use TypeScript as our language, React as our front-end library, and Next.js as our framework. And then we'll use Cursor as our AI code editor. Now I'll go over all of this in detail, but just to give you a mile-high view, you can think of the language as how we write our application. So we have languages like English, Spanish. So in our case here, we're using a modern version of JavaScript that's called TypeScript. Now TypeScript is basically the same thing as JavaScript. It's just more modern. Like I mentioned, it's kind of gives you safer typing development. And you typically use this in modern web apps. And then following this, we have the front end. So you can think of front end as everything you see on the outside of the application. So this is the design. This is the actual web page that you load on the browser. This is also the fonts you use, sizes. This is just everything that's displayed on your screen. So for the front end design, we're using something called React, which is a modern front end library that combines all traditional front end code into one simple to use library. So you can think of React here as basically a simplified library where you can easily make design changes and structure out your application. And then following this, we have Tailwind CSS. So you can think of Tailwind CSS as just basically pre-built classes. So these are just preset styles. So rather than typing in, for example, if you want an H1 title to be font size 40, font color red, font type Calibri, instead of doing all this, you can simply go to Tailwind CSS, find a preset that you like, and essentially reference this across your entire application. This just makes it so you don't need to create design presets across your app, and you can just use Tailwind. And then following this, we also have Next.js as essentially our framework that connects the front end and the back end. So you can think of Next.js as tying everything together. And we'll touch up on this in more detail. And then following this, we have the backend, which is all the things that happen in your app behind the scenes that you can't physically see. So when databases are updated, when you're authenticating new users on your application, or if there's any business logic that's being implemented in your app, or even algorithms that are used, these are all backend functions. So for our backend, we'll be using Supabase, which offers a database and authentication for the simplest way to save information in your application and authenticate users in your app as well. Because we are using NextJS as a full stack framework, we can also use NextJS for routing complex logic and connecting everything together, like I mentioned. So now let's begin covering the front end and back end at a high level. So let's start with front end development. So React is a front-end library that combines and simplifies traditional front-end code, which is made up of HTML, CSS, and JavaScript. So you can think of HTML as the page structure. So this is where you separate out titles from paragraphs. This is where you can change the metadata of the page. So basically, HTML is the skeleton of your entire web page. Following this, we have CSS, which is the styling of the page. So you can think of font sizes, font colors, font types. And then lastly, we have JavaScript code, which is used as interactions on the page. So for example, when you click a button, XYZ happens. This is all JavaScript code. So with React, it makes writing front-end code with HTML, CSS, and JavaScript a bit more simple and efficient by combining all three into a more easy-to-use language. Now, modern front-end React development is made up of 4 concepts that are built on top of HTML, CSS, and JavaScript. So these 4 are components, props, state, and basic hooks. Now let's first go over components in detail. So components are essentially reusable elements inside your application. So headers, footers, and hero sections of a website, for example, are components. The reason for this is because you reuse the header and the footer in multiple pages of your app. So if you're Apple, right, and you go to apple.com, you have a header and a footer, but if you go to apple.com/shop, you'll also have the same header and footer. Because we're reusing those elements, we'll basically create them as components within React. So when you have an app with many instances of an element, the AI will generate components for you, which are then reusable across all pages of your application. And it's important to know this because when you do want to edit the header or footer, you'll know to edit the component file and not the actual page that it's situated on. Because again, you can think of components as templates that are being reused across many different instances of your whole entire application. So with components, this is the basis of how React works. So with React, pages are also considered components, so that the way an actual page is structured in your web app is also the same way that a component is structured. So now let's take a deep dive into how components and pages are structured within React. So I've gone ahead and pulled up an example of a Tesla clone website created within V0. So as we can see, we have inside our backend code a separate folder for components and then a separate folder for apps. Now I'll go over the structure in more detail since this is going to be the framework on how Next.js works. But for now, just remember that the app folder has all of the actual pages inside our application. So in our case here, this is the only page. So that's why we only have one page.tsx file. And then the components folder is separate from the main app folder. And this components folder should have all of the different components in our application. So again, because components are reusable elements, this means that the footer here, the header, and the hero section can all be placed anywhere in our app as many times as we want. So now let's go ahead and break the structure of components down, starting from a very mile-high view. So just complete basics, these components always start with import and export functions. So import just basically means that we're importing other files to be used inside this file, or we're importing other components or default elements that's provided from either Next.js or any framework or library that we're using, and we're using it here. So importing just imports all the necessary things we need to make this file work. Now in our case here, we're importing a link from NextLink. All this means is that we're importing the link component or the link functionality that's provided within Next.js. Now we already have this installed, that's why we don't need a separate file for this. And then below this, we're also importing useState, which I will go over. This is an example of a hook, which is one of the 4 core components of React. Now export allows whatever component we're inside to be imported to another file. So that's why we always need an export function inside all of our components. So as you can see here, inside our footer, header, hero section, we're always exporting the footer, header, and hero section. And you can think of it like this. So you can import anything from your code base as long as the file that you're importing has this export function here. So the export function just means, hey, we can use this code right here elsewhere in our application. So if we then want to head over to our landing page, which is this page.tsx file, because we have this export function here on the footer, header, and hero section, we're then able to import all three of these directly into our landing page. So that's the reason why you see all these import and export functions at the top of all of your files. And then later on in the code, all this does is import these three components, but we're not actually doing anything with the components. We need to actually call on them and use them. So that's what tags are for. So later on in the code, we can see that we're now importing this header. So this just angle bracket means we're opening a tag, creating the header, and then this slash right angle bracket just means we're closing the header. So all this means is that we're creating a header and then closing the header. So for this, we're creating the hero section, and then we're adding in some additional details, which we'll go over, and then we'll close the hero section. So this is the way all of your apps will be structured. There's always going to be an open tag, close tag, and everything in between is kind of like the child element. So we have three versions of the hero section. And then at the end, we're opening up for another element. We're creating the footer, and then we're closing the footer. And then this will be the end of the footer. So you can kind of visualize how this will look. It will start with the header, three different hero sections, and then end with the footer. Let's head back into our preview. Has our header, one hero section, two hero section, three hero section, and then it ends with a footer here. So heading back into our code, this is what it looks like. So typically in almost all web apps with Next.js and React, you would make the header and footer a component. And then again, you would have the export functions at the top so that you're able to import them into the file that it's situated on. In our case, we only have a landing page here. Now let's take a deeper look at the structure of our header component beyond just the import and export functions here. So to start, these components will typically have a JavaScript function. So this is what the JavaScript function here is. And the way you'll know is because it's defined by either const or let. So this will either say const or it could say let. What this means is that const is a constant value and let means the value will change in the function. So in our case here, we're setting the menu open to be false to start with useState. And then we'll go over this useState in more detail because again, this is one of the core components of React. But just know that because this is defined as a const function, this will always be set to false in the states. And just know that these functions are where we can define variables and states of elements. And when you want to know what the function does, just simply copy and paste the function into the AI to have it explain it. And then below all of our functions that we define, we have the return section. So this will show all of the CSS and HTML code. So the return will basically have all the UI and elements that we physically see on our end. So our page will not change unless we edit this return section. And this is the structure for all React-based components. So anything above the return section here is essentially the kitchen of the component. So this is where we first import all the necessary elements that we need for the file. We're not actually using the imports, we're just importing it. So again, we need to physically use it by opening a tag and setting it to link. Again, we're just importing everything. And then below this, we're also creating any JavaScript logic for functions. We can also define variables. We can also set states, which we'll go over. And then we can also do calculations. So everything here is just the kitchen. But below this, we have the return section. And then in the return section is all the UI, HTML, and CSS code. And this is where we can actually use all of the functions and variables that we defined up top. So all we're doing is defining it here and doing some calculations. But in the return is where we actually use this code. So again, any code can be executed above the return function, but return essentially shows the front end of our application and it returns what we see on our computer screen. So inside this return section, let's just quickly go over how this is kind of structured just so you know. This is example of HTML. We're defining headers, navs, and again, everything within React will also have open and close tags. So to start, we can see that the header is the parent tag, and that's because we're inside the header component. So everything should be nested within the header. So everything below the header, we have a nav, some div blocks. These are all children tags inside this parent tag because we're opening the header here and then we're closing the header here at the bottom. So this means that everything in between is nested within our main header tag. And then to the right of the header tag, we can see we're setting some spacing of top, left, right. This is just general CSS styling. And then below this, we have our first child, which is the nav, where once again, we'll open it with the left bracket tag here. So this is the nav, and then we close it down here below. So everything inside this section is considered part of the nav. And then below this, we have a state for when the menu is open. So this is what your page will look like when someone actually clicks the menu open. And again, we were able to first set links just like we do up here. We're able to set CSS styles, so colors, happens when you hover over the text, etc. So again, all of this front end code is pretty self-explanatory once you understand the general structure of it. Plus, you can always have AI explain what everything does just so you know what to change when the AI gets stuck. Now let's go over props. Props are essentially how we pass custom data between components. So you can think of these like function parameters, and they allow us to make our components both dynamic and reusable. So components are typically only reusable. So if you use a header and a footer as a component, this header and footer will always look the same. But if you set your hero section, for example, to be a prop, you can now call the same component. So you can first import the hero section and it has the same styling, but then you can change the title of the hero section. You can change some other data on this hero section component by turning it into a prop. And this is how we make custom components while still helping the component be reusable and flexible, just with different data. So just to show you what I mean, inside this Tesla website clone, this component that we created called the hero section is actually a prop. So as you can see here, we're setting the hero section to be a prop, and the three things, so the three pieces of data that are customizable within this hero section is the title, subtitle, and background image. So as we can see here, we're first setting this to be able to be exported so that we can import this hero section, and we're setting the three different types of data that will change depending on what we actually set inside the return section there, which I'll show you. But inside this return section, we can see that the three props or the three different data points that will change is this background image first here, also the title, and then the subtitle. So what we're doing here is just setting all of the style for this hero section. So we're still setting all the font colors, the spacing, the font types. We have when things are hovered. We're setting classes for everything. So you can think of this as the template for the prop. But then inside our main landing page, when we're actually opening and closing a tag with the prop, we can now define the title, subtitle, and background image. So as you can see here in our first hero section, it's going to be a model 3, the lease, and then this image. So if we go to our preview, we can see that the first hero section here is this model 3. And then our next hero section is the same exact structure. So we're keeping the font color, the font types, as you can see, same exact font. Background image didn't load, but again, it all has the same styling. The only thing that's different is this title. Instead of model 3, it's model Y. Second is the subtitle. Instead of 349, it says order online. And then for the background image, again, this didn't load properly, but those are the three different props that are changing. So this is how we can use a component called the header section. What we're doing is creating this component 4 times. And rather than having, for example, like hero section 1, hero section 2, hero section 3, hero section 4 as 4 different components, we're just creating one template component. And by using props, we're able to pass different data into one component. So in our case, we're passing the title, subtitle, and background image. It's as easy as just simply defining the title, subtitle, background image. And again, this is what it looks on the hero section. We just have to make sure we're exporting it correctly. And we're saying that the only 3 things that will change are strings. These are the data types. So title, subtitle, background image. And this is the return section. So again, if you're working with props inside your application, you should first be able to recognize that it is a prop just simply by looking at the structure. And once you do know that it's a prop, you'll know that if you want to change the data and AI is having some form of issues, all you can do is simply go into the page that's referencing the props and importing it and just simply change the data directly. Or you can recognize why AI is kind of causing issues, or if it's looking at the wrong file, or if you do want to change the actual template and styling of the entire hero section rather than just the data, you'll know that you'll need to edit the actual file inside our components folder here by adjusting this return section, which once again shows everything on the screen. So this is just the kitchen of the hero section component. This is what's actually being shown on the screen. Now let's go over the third core component of React, which is state. So state is how we handle data that changes within components. So basically you can think of state as the memory within your component. So it remembers info and updates the UI based on when the info changes. So an example of this is a like button that changes color when it's clicked, a counter that increases or decreases, a form that stores user inputs, and a shopping cart that updates items. You will almost always see state being used in AI generated code when they have you make a front end design, since things will change colors or change text as soon as you interact with them on websites. So I know that we looked at use state inside our V0 example, but I've gone ahead and just pasted in some code just to show you how this looks like in a more detailed way. And this will kind of explain and show the flow for everything. So this is a component that's using states. And as you can see, we'll always have an import function at the top of our code base that's telling our code base, hey, we're using states inside this function. So basically, whenever you're using states somewhere inside your code, you'll always need to import useState from React. So we'll always need this function whenever using states. And then below this, like I mentioned, this will essentially be the kitchen of your component, whereas the return section will be everything that's shown on the UI. So inside this kitchen here, what we're doing is first defining the default states. So right now for our like button, because it's const, it's always going to be set to false. That means our like button state will be false to start, and it will always be false. So that this is basically the kitchen. This is where we're defining the state. And then below this, the return section is everything we see on the screen, so that when you click the button inside the front end, it will then change to is liked to liked, and then the color will change from black to red. So all this is saying is that on click, the button will now be set to is liked. Because again, if you remember at this top section here, the state of is liked is false, so it's not liked. But then on click, it will be set to is liked. And then below this, we're just defining the style. So the style for the color, if it's liked, then it's red. If it's not liked, then it's black. Okay, so this is how everything works with use states. States are just basically memory. So these states give components memory. In our case, we need a memory if a button is clicked or not clicked. In our case, liked or not liked. So this is the memory here, and the starting memory with this const function is that the state of this memory of is liked always starts at false. But then below this, so this is the starting memory, and then below this, we're able to change the memory based on what the user does in the front end. So if they click, it will change this memory of the state to be true, and this will thus change the style of the button from black to red. So you can use states for a myriad of different examples, but in a lot of cases, even with just simple web apps, you'll always use states to change the visual components of an element based on how a user interacts with that given element. And one thing to know also is that with state, the UI updates. So this is a very neat component about use states, so that whenever a user clicks a button, for example, they don't need to refresh. This will automatically update on the web app. And if you are using use states, then every component will always start with a default state. In our case, the is liked state will always be set to false. Now, React hooks are the final core part of modern React development. So hooks are basically just special functions in React that let us add extra features to components. And we actually just used one in the previous section with use state. So now React hooks will always start with the word use. So whenever you see used, you'll know that it's a React hook. So typically when AI generates front-end code, you'll see a lot of use functions. Again, these are just special functions. And the two most basic hooks are use state and use effect. So we just learned use state, which we imported in the first line of our code snippet. And useEffect is mainly used for handling side effects, which we'll show. But there are dozens of other use React hooks that you can just simply have AI explain what they do. And it's important to recognize when AI is using hooks inside your files because there's just some nomenclature that you have to add to make sure that your code is working. So basically state is what we just learned, which is the concept of changing data with the component memory. So useState is a hook, which is the actual function we use to implement the state. And because we already went over useState, let's now quickly go over useEffect. So useEffect is setting up automatic actions inside components. It's like saying when this happens, do this thing automatically. So you'll see this for loading data when a page opens, setting up timers, connecting to services. These are just assistants that wait for certain things to happen inside your app. And once that certain thing happens, it'll trigger like clicking a button, and then it will do the task automatically. So that's what useEffect is. And then moving on, here's an example of a component using useEffect. So useEffect runs when the component loads and gets data. And this is the general structure for how it looks like syntax wise. So you'll need an empty array. And then again, since AI is generating this, you don't need to know the ins and outs of syntax. You just need to know what this all generally means. Now, the final thing to note here is that React hooks need to be made as client components. So when you're using React features like hooks, you'll need to add a used client function here at the very top of your code. So if AI is generating code for you and you're getting a client error, you need to add the statement at the top of all your files that use React hooks. Now, the last thing to cover here is React events. Now, even though it's not a core component of React, events are still very common with AI generated code. So React events are basically how we handle user interactions within components. So the most common ones that you'll see within AI generated code is either on change or on click. So on change handles when a user types something. On click, which we've seen in previous examples, is when a user clicks something. So we had a button with the on click event that would change the state of the button from liked to not liked. And then apart from this, we also have on submit, which handles when a user submits a form. So these basically make components interactive and actually are used with states, which we learned previously. So for example, you want to update the text as the user types. You want to change colors when it's clicked, which we saw in the previous example. You also want to show and hide elements and submit form data. And like React hooks, events also need a use client function at the top of the code. This section should cover everything you need to be able to understand AI generated front-end code at a high level. Now, I can't cover all of the different types of React hooks you'll encounter or all the different types of JavaScript functions you'll see, because again, there are hundreds. But what's important to know is the structure and how they work at its core. Because once you know the structure and how they work and how you know where to hone in on something, you can essentially have AI explain what a specific function does or what a hook does, just so you have the lay of the land of how your app is being structured. And with this, you can easily tell AI what to change and even what might be causing an issue inside your application. Another thing to remember is that AI supercharges you, so you don't need to know it all, but a good foundation in this section will really pay dividends, especially when you're having trouble updating the style of something pretty trivial like a button. If it's nested within a component and you're trying to update the page.tsx file, you'll know that you need to update the component. Or if you're using props, for example, you'll know that you need to update the component for the styles, but the individual page that's calling the props, if you want to update the data, just small things like that, you'll pick up pretty quickly on how your app is being structured. And just having this slight kind of foundation, in addition to AI explaining what functions you're using inside the code and the nitty gritty, will really supercharge you and help you in building out complex applications. Now let's do a deep dive into how your app is actually being structured within the NextJS framework. So like I mentioned, NextJS is a full stack framework that essentially ties everything together. So it combines what we learned in the front end with React, and it helps us essentially structure out our entire application and connect to our backend with Supabase. So I've gone ahead and opened up a completely blank Next.js project. All I've done is essentially rewrite the page.tsx file to be a hello world function. But other than that, this is just a very default and standard boilerplate Next.js folder structure. So coming down here for the structure, almost all of the code that AI generates for your Next.js project will all be within this app folder. So you can think of this app folder as the actual portions of your application. So as you can see, we currently have a page.tsx file inside our main app folder. So this will essentially be our landing page or home page. So the page.tsx file that's directly underneath our app folder is just the first page that everyone will see in your app. So if you want to create a second page inside your Next.js project, so for example, if you wanted to create a pricing page, you would first click into this app folder that we have, because once again, all of the different pages and components and files inside our application will all be inside this app folder. And then from here, we would first have to create a new folder before a new file. So example, if we want to create a new pricing page, you would first create a new folder, call this pricing. And then inside this pricing folder, you then want to create a new file called page.tsx. So folders in Next.js are basically URL routes, while the page.tsx file inside the folder is the actual page content. So again, just to repeat myself, we have an app folder. So we have a page.tsx file here, which is just the main page of the app. And if we wanted to create a pricing page, so if our app was called apple.com and this was apple.com/pricing, we'd first have to create a new folder called pricing and then create a new page.tsx file inside the pricing folder. So an important thing to note, especially within Next.js, is all of the individual content pages or pages full of the return code is all just called page.tsx. So if we wanted to create another URL route inside our pricing folder, we would then create, once again, another folder. We can call this basic plan. And then inside this basic plan folder, we can create a file. Once again, all of the files will be called page.tsx. So what this means is that we now have a page that's inside our app. So /pricing/basic plan. And then this will be the contents of that page. So this is how structure in Next.js works within your application. So whenever you want to create a new page, just create a new folder and then just stick a page.tsx file inside that new folder. And if you want the page to be nested within another page, so for example, here we have our basic plan folder nested within our pricing. You'd first make sure that you're inside the pricing folder and then create a second folder called basic plan. And then the contents of that folder will once again be the page.tsx file. And then again, all of your content files for every single page in your app will all be called page.tsx or page.js if you're using JavaScript instead of TypeScript. So to really visualize how Next.js routing works, here's what Apple would do. So if your Next.js project is called Apple, then the website, or assuming you have a domain, would be called apple.com. So if you type in apple.com, you'll be directed to the page.tsx file that's directly within the app folder. So like I mentioned, this is the main page file, and this is the first page that everyone sees in your application. So inside your app folder, the page.tsx file is essentially your home page or landing page. And then if you wanted to create apple.com/pricing, you'd first create a pricing folder and then create a page.tsx file. And then all of the contents of this page.tsx file would show on apple.com/pricing. And then once again, if you want to create a new page that's nested within the pricing folder called updated. So if you want this new URL to be apple.com/pricing/updated, you would first head over into the pricing folder, create a new folder called updated, and then the contents of that folder will be this one singular page.tsx file. And this will show essentially this URL route. So this page.tsx file will now map to apple.com/pricing/updated because we're nesting our updated folder inside the pricing folder. And then again, like I mentioned, every single file within all of these routes are all called page.tsx. And then if you wanted to create an about section, but this doesn't have anything to do with the pricing section here, then we can do directly inside the app folder, then create a new folder called about so that it's not nested within pricing or updated. So now this new URL route or the page.tsx file will now route to apple.com/about. And then below this, we have dynamic pages. So I'll quickly go over what dynamic pages are here. So dynamic pages essentially let you create pages that change based on data. So these are basically template pages with fill in the blank URLs. And these are most commonly used for blog posts. So the URL would be right here, blog post, post 1, post 2, post 3. It can also be used for product pages if you have an e-commerce site. So it could be /products/shirt/pants/long sleeve shirt, or it can be user profiles. So it'd be apple.com/user, and then it'd be /John/Jane, etc. So basically what you need to do is first create the main folder, which would host your dynamic pages. So in our case, in this example here, we have blogs as our dynamic page. So inside the app folder, we just create a blog folder with a main blog page. So this apple.com/blog is just this main page.tsx file, which essentially shows all of your blog posts. But then if you want dynamic pages after this, so you want a blog post 1, post 2, post 3, you would then have to create this bracket ID. So what we have here is a bracket ID called slug. So this is the dynamic root or element here. And then after this dynamic root, you would do a page.tsx. But the important thing here is that you only need to create one page.tsx file because we're defining a dynamic root here. So if we didn't want to use a dynamic root and we had 100 blog posts, we would then have to create page.tsx, another folder, page.tsx, another folder, page.tsx. So all these dynamic roots do is essentially simplify different versions of the same page. So again, if you have multiple blog posts, but they all share the same structure, all you need is this one dynamic root and then one page.tsx file. And then the page.tsx file would have its content change based on the parameters that are being passed. So again, great for blogs, user profiles, and just different products if you have an e-commerce site. So if you are making dynamic pages, just remember the structure here in case AI messes up somewhere along the way. And if you do know that you want to make dynamic roots, then you can kind of tell AI like, we want to have a dynamic root here. And if you ever see this structure, you know that this is a dynamic root so that we have one page.tsx file for multiple different template pages. So essentially in a nutshell, dynamic pages are just template pages that you update. So instead of updating all the different dynamic pages, you can just update this one page.tsx file and have different types of data pass through here. And then this is what it looks like within the actual dynamic page. So if we clicked into this page.tsx file within our dynamic root, this is what the dynamic page looks like. So like I mentioned, it's passing over parameters because every single page will be different depending on the actual data here. So in our export section, we have different parameters for what the post will be. So the post will be based on the parameters and the ID. Now let's go over some of the more default files that come with every single Next.js project. So as we see here, we have first, let's go down the list. We have a layout.tsx file. So what this is just a container that basically makes rules for all of your page.tsx files. So this page inside our pricing basic plan, as well as our page directly within pricing, as well as just our landing page here, they will all follow this layout.tsx file. So inside this layout file, we can see all of the HTML default settings for our files. What this means is that all our page.tsx files follow this. The only thing that will change is the actual children's section, which are the different types of content within each of our page files. Next, we have our globals.css, and you can think of this as global styling for your entire app. So with this file, you can make changes to colors, text size, font, and it'll make all these changes in all of the files in your project. So whenever you want to change global styles, you would need to update this globals.css file. And if you're trying to just update one specific component and you see the AI updating this globals file, you'll know that you need to stop this from occurring or define CSS classes to use in the component. So inside this globals.css file, you can also create CSS classes, which just like components are just reusable CSS properties to keep your code from being messy. So you would need to define the CSS classes here inside this globals file. So you can say something like black text equals, and then you can choose the font color and then the font family. And then you can reference the classes in your individual page.tsx file. So inside this page file here, rather than defining the actual font, saying it's bold, etc., you can just reference the classes that we had individually inside this globals.css file. And if you don't want to define any classes at all, you can also just reference the standard Tailwind.css classes. So like I mentioned, Tailwind is something built on top of CSS that we're also using in our tech stack by default. So this is something that you can turn on with Next.js that pretty much everyone does. And this just gives you hundreds of pre-built CSS classes that you don't actually need to define inside this globals.css file. All you need to do is just simply reference it. And because we already have the dependencies for Tailwind CSS installed, you don't need to define the classes at all. Just directly reference the class name inside your page.tsx file, and you'll be able to see all of the default stylings applied. So if you want to know all of the list of classes for you to use, you can simply go to Tailwind CSS docs to see the list of classes that you can immediately use. So these are some things like H1 classes, more stylized body text, etc. So there's literally hundreds you can choose from within this Tailwind CSS docs. And then lastly, we have our package.json file. So this is essentially the control center for your entire project. You'll have your project name, which we called Git. We'll have versions as well as general info on the project. And then below this will show all of the dependencies or packages that we have downloaded for our project here. So like I mentioned, we made this into a Next.js project. This is just the default Next.js project. So we have React installed because again, Next.js is built on top of React. We also have Next installed because again, it's a Next.js project. Then we're using TypeScript. Once again, we're using React. And then we have Tailwind CSS enabled as well as ESLint enabled, which again is safe typing. These are all of just the settings that you essentially choose when you create a default Next.js project. It'll ask you if you want to use TypeScript, if you want to use Tailwind CSS, if you want to enable ESLint. So these are just all of the settings that we enabled, and then Next.js installed all of these dependencies for us. So if you ever want to see what packages are installed inside your project, just simply go to this package.json file to see all of the project details on your specific project. And then any other packages you install using your terminal will show up here. So like I mentioned, these are just everything that's essentially installed inside this project. And you typically don't need to ever edit these, so don't touch these. And then the rest are all just default files. We'll go over git ignore inside this git section. But other than that, everything else is pretty much standard. You don't need to touch everything. Just remember that essentially all of your app will be inside this app folder. The only major changes you would make apart from this app folder would be a components folder if you're using components, and then this globals.css, layout.tsx, and then this is the landing page. And then finally, we have a public folder. So if you want to create public assets that anyone can access, so these would just basically be images in your web page. You can essentially paste in addresses for images or videos into this public folder. So in our file here, we're using some SVGs. So this will just be all of the assets to be used inside your project. Now that we've covered modern React development with the front-end library, as well as the Next.js framework, let's now go over how to actually connect your front-end with your back-end through the use of APIs. So APIs are a set of rules that allow software to communicate with each other. So APIs are commonly used to update data and set data inside your database, and it essentially connects with a backend server through the use of API endpoints, but that's getting a little bit too technical. So in our case, all we need APIs to do is connect our front-end code, which is everything we learned in React, to our backend, which will be Supabase, to access Supabase's database and authentication data for our users. So moving on here, APIs are also used to connect to third-party software to use their services. So this is only if you plan on using third-party APIs, but if you want to connect to OpenAI's API to use their ChatGPT model in your app, which is what all AI apps do, you would use their API. You can connect to IMDb's API to get a movie database in your app. And you can also connect to Spotify's API to get a music database in your application. But moving on here, let's just focus on strictly front end to back end. So to create a front end or to connect a front end and a back end, you'll need HTTP requests. So you can think of these requests like sending messages between the front end, which is again what the users see, and the back end, which is where the data is processed. So the front end sends a request when a user clicks a button, they submit a form, they load a page or some other type of interaction, and the backend processes this request by reading your database. It can save new data, it can update data, or it can delete data. And then once it does one of these 4 functions, the backend then sends a response back to the front end through either a success or error message, the requested data, or updated information. So an example of this is, say if a user clicks a button, it'll show the user its current, rankings within the website. So what this would look like is front end sends a request by the user clicking a button, and then the back end, all it's doing is reading the database, because again, we want to show the user's rankings. We don't want to update any data within the database. So all this is doing is reading the database, and then it'll send a response back with the requested data. So this is how that workflow would look like. But say, for example, a user types in a new email, and then it wants to change the user's email inside our database. What they would do is first type in the email, submit a form. So this is when the front end sends a request, and then the back end processes the request by then updating data, right? Because we're actually physically updating data within the database. And then the back end then sends a response back to the front end. So what we see on the front end is either a success or error message saying that your information has been successfully updated or it hasn't. Now, await functions are how we're actually making these HTTP requests to connect the front end and the back end. So these requests, like I mentioned, help connect the two. And await basically means that you're awaiting data, which takes time. So the reason why we use await functions for HTTP requests are because it takes time to first receive data or update data in the backend. So like I mentioned, if we're doing this whole process where a user clicks a button, we'll need an await function, because after the user clicks a button, the backend has to do all this before sending a message back. This is why we need to await the data that's completed from here, and then the data will then return from here. So again, this is getting a bit nitty gritty, but just to show you what this looks like, there are 4 different types of HTTP requests that are sent from the front end to the back end. So the 4 types of requests are get, post, put or patch, and delete. So moving on here, get requests are used to fetch data. So it's like asking, can I see all recipes? Get requests don't change any data. It only reads existing data from the database. So an example of this that I've shown here is loading recipes when a page loads. Now you don't need to know the exact syntax, but you should just understand what's happening here. This is a get request. And like I mentioned, we're using this await function, which we covered, because we're awaiting data and we're getting it from Supabase from the recipes. So all we're doing is getting data. That's why we're using this get request. Next is post. And we're using post request to create new data. So this is like saying, here's a new recipe to save. It sends data to be stored. So an example of this is submitting a new recipe form. So right here, we have this await, and then we're creating a new recipe within our recipes database. All this HTTP request doing is essentially connecting our front end to Supabase and having Supabase within their own dashboard update all the information for us. Next, we have put patch requests, which updates existing data. So like updating existing recipes in your database. In the front end, you type the recipe, and then the new recipe gets sent to your backend database and updates. So this line here, this HTTP request await function, is essentially the bridge between the front end and the back end. So obviously in the front end, the user has to do something like click a button, and this bridge helps connect our front end in real time to the Supabase backend so that Supabase can update, for example, recipes here. And then the last request is a delete request. This removes data from existing recipes in your database, for example. So if you were to click a button in the front end, it would then delete a recipe in the backend database. Again, we're using an await function. Supabase from recipes, delete. So this is what all these await functions look like. And whenever you see these types of functions, you'll know that this is essentially connecting your front end, which is how the user sees your application, to the backend, which is what you don't see. It's what everything is on Supabase. And this is how the bridge connects the two essentially. So in a nutshell, whenever you're making a request or updating data inside your backend, so your database/authentication, you'll need to make HTTP requests to communicate between your front end and backend. So like I mentioned, we're going to be using Supabase as our backend, and Supabase is what's known actually as a backend as a service. So this is a simplified type of backend that handles all the heavy lifting for us. So we'll use Supabase to authenticate users, save and update data in our database, as well as delete data, and also perform backend logic. So with Supabase, we don't need to write out any complex backend code. It handles it all for us. So all we need to do is just make these requests to Supabase, which is a lot simpler than creating your own routing files and creating API endpoints for you to update this automatically. So with these simplified HTTP requests, it's just one line of code to connect to Supabase and have them either create or read, create, update, or delete requests for us. So we'll go over the Supabase platform in detail during the app build through section, so you'll know how to set up Supabase properly, how to use Supabase to authenticate users, and how to use Supabase as an external database so that it can store data for your users. Now let's go over debugging with AI, since you already have all of the fundamentals down and how an AI app is being structured and how to understand the code that the AI is generating for you. So moving on here, oftentimes when working with AI, you will encounter debugging issues. And these are inevitable when generating code with AI, but our background that we spent time on here will be of immense help. So before I dive into the typical workflow, let's first go over some of the most common AI errors you'll typically see. So the first most common AI error is that it's missing the use client at the top of the file. So again, you need this if you're using hooks or React events, which we learned we needed. This is an easy fix, but obviously if you don't have this background knowledge, you could spend possibly even hours just spinning your wheels, wondering why your files aren't working. The second most common error is wrong import paths. Once again, this is an easy fix. We learned that we need to properly import components that we're going to be using in our page files. It's just important to make sure that the paths are correct. So look at where your folders are located, if they're nested within other folders, and make sure to reference the proper folder when you're importing something. Next is missing dependencies, and this is simple. You just need to download dependencies that your app needs. So you can simply ask AI if you're missing files and what commands to run in the terminal to download your necessary dependencies. And then again, you can open up the package.json file to show all of your current dependencies. This way you can actually have AI read this file for you and let you know if you're missing anything inside your application. Next is wrong file structure. Again, with our in-depth NextJS section that we just covered, you should know how your entire code base should now be structured. So this shouldn't cause any issues for you unless you're dealing with a very, very complex code base. And then lastly, we have syntax errors, which can be easily fixed with AI as long as you load the proper documentation into the LLM models that you're using. So here's an example of what errors in your code looks like. So for missing this use client at the top of the file, it'll stay error use state is not defined. If it's a wrong import path, you can say it can't find this specific component. If there's API call issues, you can say that fetch is not defined. Again, we covered all of these different scenarios in our previous sections. So with that basic fundamental, you should be able to debug most of the AI errors that come out on your own. And as you can see, we essentially covered all of this. And this fundamental knowledge will essentially make us 100 times more efficient with AI tools. And if you didn't have this background knowledge, you would essentially be complete beginners scrambling for days, wondering what an import path even is, and etc. So this is why it's important to just spend this extra bit of time on the fundamentals. Now let's go over how to fix errors that we don't fully understand. So first, you want to make sure to copy the full error message. You then want to ask AI to explain it in simple terms. So in our case here, if your error deals with the front end, you'll get the error message when you open up your app's localhost browser and go to the browser console. And if your error deals with the back end, you'll get the error message directly inside your system terminal, which we'll see when we're actually building out our full stack application. So once you actually are able to copy the full error message, You then want to ask AI to, once again, explain the error in simple terms. So if this is an easy fix based on our fundamental knowledge, we can immediately just fill in the gaps, have AI do a quick fix, or even do it ourselves. But if it's a bit more complex, then you would ask for a step-by-step fix. So again, if it's a simple fix, you can just have AI make changes. But if it's complex, you need to make sure to do everything slowly and step by step. So it's important to make sure to share relevant code and your file structure when you're dealing with AI. So let me just go over where to find AI error messages in more detail. So going on where to find errors, like I mentioned, there are two main errors you'll see in your application, which is either in the front end or back end. So again, the front end is its design, back end deals with all of your database, etc. So front end errors are found in the browser. So when you run your application, you'll do npm run dev and then go to your local URL. And then from there, if you right click the browser and open up the console, this is where you'll see the error. And these are typically from failed API calls. Now the backend errors are actually just found directly in your computer's terminal. So if you're using cursor or replit, you can just simply scroll up from the bottom, get the terminal, and it'll show you what's actually going wrong inside your code there. So these server errors or backend errors are essentially if you're missing an import statement in a React component or something else. So now moving on here, let's now go over error states. So now that you know, or before error states, let's go over how to implement fixes. So now that you know how to find errors and how to provide the errors to AI, let's go over how to implement and understand the errors. So first, AI will typically start console logging to see where the error is occurring in your code. So like we learned earlier, console logging just displays a message to your terminal or browser console. So in our example here, AI is adding console logs every step of the way to see where the issue lies. So right now we have a console log in 3 different places. And once again, the console log results will appear in your terminal or console so that you can see the specific line where the code is failing. So this first console log here is checking the response. So if we ran the app inside our terminal, we'll see a response that says either yes or no. And then this second console log here is checking the data. So it'll say whether it's successful or not. And then this third console error is actually logging any errors directly in our console. So if these console logs are in your front end files, so your page.tsx files or components, then you go to your local host server, open up the browser console to see the logs. And if console logs and error logs are placed in your API files for your backend, you then go to your terminal from your IDE or your computer to see the logs. So an important note here is that the console logs and error logs will always show your terminal or browser console, never your front end or what people see in your app. So again, all of these errors that you'll see will always be inside either a terminal or browser console. These errors will never physically show up on your application unless you define them through error states. So sometimes AI will implement error states. Like I mentioned, will show errors in your app and display them directly in your UI. So you can directly see the error in your app and have AI fix them accordingly. So in our example here, we're adding error states, and then it's going to show the errors directly in the UI. So it'll say error, or if there's no error, it'll just say loading. So this is a way to actually see directly in your front end if something wrong is occurring. So now knowing all of this, we now have all of the background information needed to debug. So this is what a debugging workflow typically looks like. First, there is an error in your application. So you first want to check the location of the error. So again, based on front end or back end error, it'll be either in the terminal or the browser console. Once you identify where the error is at, you then want to copy the error message and then share the error with AI and add some context behind the error. So you can add the specific code files where the error is breaking. You can also add the file structure of your application in case there's any import paths that are essentially being unrecognized. And then lastly, you want to implement a fix step by step and slowly. And for best practices, you want to always test after each fix, keep track of what worked, and really understand the fixes that AI is undergoing. Now, before we start building out our application, there's just 2 things we need to install The first is Node.js, and what this does is help us run the JavaScript code that we're writing. So if you recall again in our language section, we're writing in TypeScript, which is just modern JavaScript. But to actually run the JavaScript, we just need to install Node.js into the computer we're running it on. This allows us to see our application when it runs. So this is free. All you have to do is just download Node.js from this website here. And then the next thing we'll need is Cursor. So what Cursor is an AI code editor. And at its core, it's essentially just VS Code, but with AI capabilities. So VS Code is an IDE. It's just somewhere where you can write code. So you can think of Cursor as just somewhere where you can write and deploy your code. But the cool thing about Cursor is that it actually offers AI capabilities. So Cursor can read your entire code base, make changes for you, as you'll see when we're building out our application. And it's, I would say, the industry standard for AI generating code compared to Windsurf or other IDEs like Bolt.new, V0, and even Lovable. Cursor has the most potential for creating complex apps. If you were to use things like Lovable or Bolt.new, you would find that it's good for creating simple apps with a one-shot prompt. All this means is that you just type in one prompt and it creates a simple app. But if you want to do anything with any sort of complexity, Cursor is your best bet since you're able to dive deep into every single different file. You can have the AI model within Cursor basically read your entire code base, make suggestions. You can roll back suggestions. It has all the functionalities of VS Code, but just with AI attached to it. So this is what we'll be using inside our build through as well. And for the pricing, you can actually start for free with Cursor. But if you find yourself hitting some limits, as most people do, the Pro model, which is at $20 a month, basically is everything you'll need to begin building any form of complex applications. But again, if you don't like Cursor, if you want to try something else, you can always just use things like GitHub Copilot or even Windsurf. I know GitHub Copilot is also free at the moment, but like I mentioned, I found that from my own testing, Cursor is the most competent when it comes to dealing with complex code bases. And you're just able to make changes much quicker. Cursor can understand your project, and you don't have as much of a headache as if you're going through Copilot or Windsurf, for example. So these are the two tools that you must download before we begin actually building out our application. Now, one key concept that you have to know when coding with AI is something called the Git. Now, let me illustrate this directly inside a codebase. So right here, I've pulled up a blank Next.js project. And all I've done is created a blank folder and turned it into a Next.js project. So it has all the default files and folders. I've changed nothing inside this project. So as you can see in our page.tsx file, this is just the standard Next.js landing page. So what Git is a version tool that lets you revert back versions of your code. So you can think of Git as version control. So it lets you go back and undo changes that you've made. But more importantly, if AI accidentally deletes lines of code or breaks your project, you can easily revert changes by going back to a Git commit. And Git also allows multiple developers to work on the same project and merge their changes together. So if you are working in tandem with someone, this could be helpful for collaboration. So to actually access this Git menu, what you want to do is click this 3-circle icon here at the top. And we can see that what we have is just one initial commit. So what this means is that this is the initial change that took our project from a completely blank project to a Next.js one. So what I did is I had a completely blank project and then I ran the Next.js commands. So from there, it created all the files and folders for us. So if we were to click into this initial commit, we can see all of the changes inside our project. So the left side here is what our project looked like before all of our changes. So again, we had none of these files because once again, this was a completely blank project. And the right side is all of the updated files, which again are just the default Next.js files that are installed when we run the dependency to create a Next.js project. So as you can see, left is the initial, right is all the changes inside this one commit. And again, these changes are all just default Next.js files and folders. So now let's go ahead and make some changes inside our code base to kind of show you how Git works. So let's first exit out of this change and let's go to our page.tsx file. So like I mentioned, this is just kind of the default landing page that Next.js gives you. So what I'll do is just delete all of this and then I'll just paste in a hello world code. So let's paste this in. And what this will do is essentially just create a blank page that says hello world. So what you want to do from here is to actually save the change. So to save the change, you just click Command S. And now our page.tsx has a blue M next to it. What this means is that our file is modified, but the changes aren't committed. So what you now want to do is head over into our Git menu. So once again, click into these three dots. And from here, we can see that we have changes below here. So what this means is that we have changes inside our file. This change here is when we removed all of the default Next.js landing page items to just have one blank page that says hello world. And then inside this change, because it's inside this changes section here, it means that we haven't implemented this into a Git version. So this change, even though it's right here inside our code base, it's updated with an M, it's not actually published anywhere. So what this means is that we have to actually commit this change if we do want to use these Git features. So the way we can commit this change is to first click on these changes to see what changed. So the left, once again, is all of the previous lines of code that we've had. So like I mentioned, inside our page.tsx file, these are all of the default Next.js components. And on the right side, all I did was remove all these lines of code and just added in one simple function that just says hello world. So the right is our updated file. The left is the file beforehand. And then if we want to actually commit this change, so what I mean by commit is that if we want to publish this change and have it actually save and we like what we have, let's first write in a message. So we can type in hello world and then let's click commit and we'll click yes. And then from here, we see that we have our initial commit that took our project from blank to a Next.js project. And then our second commit that took our Next.js project into one that just says hello world. So this is how you can essentially see version control inside your project. And then in the menu below, this is our first commit, initial commit, and this is our first published commit. So this was done initially just by default. And then any additional changes that we make will continually show up inside the source control center here. Great. So now just to show you how this kind of works, let's head back into our page.tsx file. And then I'll just do simple changes just to illustrate. But if we wanted to change this to a number, we can do hello world 1. Once again, click Command S to save these changes. Once again, it'll have an M for modified, which means that there are changes that aren't staged. We'll head over once again to this Git section, click on the change. You can see the old is hello world. And now we have hello world with the updated number 1. So if we like this change, we can say hello world 1. And this is just the description. So you want to be as clear as possible as to what you're actually committing here. So if you said like added a new button component or add an XYZ feature, you would add that here, then click commit. Once again, click yes. And as you can see, we have our hello world 1 change here. If you click on it, we can see what's changed in our project. So on the left-hand section here, we have our previous hello world, and on the right-hand section is hello world 1. So this is just a quick rundown of how Git actually works within your project. So now inside our source control graph here, we have a timeline of all the Git commits we've done in our code base so far. And because we have all of these different kind of like checkpoints, you can actually revert to a previous commit. So say for example, we didn't like any of these changes and we wanted to revert back to this initial commit before we made any changes to our landing page with the hello world. All we can do is simply right click here and click copy commit ID. Then what you'd want to do is open up the terminal. So we can open up the integrated terminal inside our IDE here, which automatically directs us to our project folder. And then from here, all you want to do is just type in git reset. And then you want to type in hard. So this will be a hard reset to this commit ID, which we just copied here. Now we can click enter and we can see that all of the previous changes have been removed and our project is now taken back to the initial commit. So once again, inside our file, let me just reload this to show you inside our page.tsx file, we no longer have the hello world changes. All we have is our initial commit. And then in this git section here, once again, it's deleted all of our previous commits because we hard resetted to this initial commit section. And then say, for example, you only wanted to revert back There's also different terminal commands, which is a hard -1, which would revert back one change. So again, I would just make sure that you're actually reverting to the git commit you want to. So make sure to look at this timeline and just know that if you revert to a change, it'll delete all of the changes above that change. So everything before that change is safe, but everything after that change that you're hard resetting to will essentially be gone. So as we can see here, because we reverted back to the initial commit, our hello world and hello world 1 git commits were all deleted. So now one issue with Git in particular is that all of these commits are saved locally on your computer. So we have this initial commit, and let me just once again make another change. So inside our page.tsx, once again, we can remove all of this, and then I will create our hello world page once again, click Command S to save, head over to our Git. We'll call this hello world change. We'll commit this change. Click yes. And again, as we can see, we have our git commit here, which removes all of this and has our hello world. So one key concept with Git is that all of this is only saved locally to your computer. So these changes here are only inside your computer. So what this means is that if your computer breaks, your code is essentially gone. And this is why people store their code online, and this is where GitHub comes in. Now, I'm sure this is a fairly standard website that you've probably heard of, but GitHub is a place where you can store your Git commits and essentially your entire code base online. So you can think of this as kind of like a Google Drive for developers, and you can make your code either public or private. So all of the code that you see or open source code that you see on GitHub is all public code, meaning that they're showing you what their Git commits look like. But you can also just simply back up all your changes and keep your code private. But it's always good to have all of your code base online, just in case anything happens to your computer. Or if you do want to access your code base from a different computer, you can easily just log into your GitHub account. And from there, you're able to actually receive the Git commits. So the way you would do this is for this hello world change. If you want to publish this branch, all you would do here is click publish branch, allow to sign in using GitHub. And then what you would do is sign into your GitHub account or create a GitHub account if you don't already have one. And then from there, you're able to store essentially all of your code on the cloud. So if your computer breaks, you still have somewhere where your source code is all present. And then the last key concept about Git here is that we have a git ignore file. So what this file does is it shows you all the folders and files that we don't want Git to track. So when we made changes in this page.tsx file, we were able to see the changes inside this menu here because that file is not inside this git ignore file. So every single file that's inside this git ignore file, Git will automatically ignore. So that means that any changes we make inside any of these files won't actually show up on this section here. Now, this is not that important, I would say, especially when developing code with AI, since you typically would never really touch these folders. These are more so just for installing dependencies or just default files that will never be touched. But if you do have a specific file that you created that you don't want Git to track changes for, you would simply type in the file here and maybe add in just like a note just to let people know what this file is supposed to do. Let's now go over the workflow for creating a full stack SaaS application. So for a full stack app, what we'll be doing is creating a CRUD app, and this is what 99% of web apps do. So it essentially creates, reads, updates, and deletes documents from users. So the first thing we'll do is go to ChatGPT or any other chat base of your preference, and you can think of how to structure your database and app. So from here, you can kind of brainstorm with the AI to think about features to add, what APIs you'll be using. So for most CRUD apps, I would just say that you'd first need a user collection. This is where you'll store information in the database about the users that are accessing your app. Then you'll have another data collection for the specific product that you're offering. So for example, if you were to create a recipe share platform, then recipes would be another data collection, and etc. So this is why it's important to work with the AI initially to figure out how you're going to structure your application. And then from here, we'll create a basic landing page just so we have somewhere to act as like the hub to connect all the different pages inside our application and for something to just look at. And then from there, we'll start working on implementing the backend. So like I mentioned, we'll be using Supabase. So from here, we can connect Supabase for authentication, database, and storage. Now, one important thing to note is that we will use the Next.js API routes for complex backend features. So this is what we learned in the API section. But as you can see, once we start building out this recipe app, if we're just simply connecting to a database or getting data, we can do this directly to Supabase rather than having to write out API routing for every single different type of data that you want to receive or edit. So this is where Supabase really comes into handy. But again, for any complex features, you will still need the API routes that Next.js provides. And then from here, you can then implement Supabase into the app to start linking the front end and back end within the application. And then you can add more complex features, restyle the front end a bit just to make everything look a bit more pretty. And then at the end, we'll also connect to Vercel to show how you can deploy your app and take it live in under, let's say, 5 minutes from starting the deployment process to actually having the app be live on a specific domain. So Vercel really does just simplify deployment at the end of it. And this is kind of the benefits of using Next.js with Vercel because they kind of work hand in hand. And then just one final thing to know is that it's always important, especially when we start working, to understand what's happening at a high level. So because you have all these fundamentals down for even front-end basics, how back-end routing works, you should understand the code that is being generated from Cursor. Now, obviously, you don't need to know all the ins and outs, but especially when you're debugging or generating new lines of code, you can easily identify if the AI is removing lines that you need from your application or if they're adding unnecessary fluff. So I would just say don't mindlessly apply every single change the AI kind of integrates. Take everything slowly, step by step, like I do, and really check to make sure that they're not breaking any specific points in your application. So now, like I briefly touched on, we can begin building our full stack application. So now let's begin and start doing a full build of our application. So in this section, we'll be creating a recipe sharing platform, which is where users can either create, edit, or delete recipes of their own and share it to our application. And then other users will be able to either view the recipes and also interact with them. So you can think of this type of application as somewhat of a SaaS with a social component added onto it, since you'll be able to view other documents created from users on the platform. So this recipe sharing platform will essentially introduce all the essential CRUD components that you need to build for basically any type of complex web app with social features. So like I mentioned, CRUD stands for create, read, update, and delete documents. So with this, users will be able to save data to our app and then access the data in our app. So this will basically be the cornerstone of all web applications, since almost every web app needs to manage data from users, ranging from social media apps, e-commerce, and even B2B tools. So the only differentiating factor is what the product actually does in terms of the offering, but at its core, and especially at its backend, you will need to deal with basic CRUD functions in every single web app. So the first thing I've gone ahead and done is head over to ChatGPT. Now, it doesn't matter too much which model you'll be using since this isn't too intensive of a workload, but what you'll want to do is create a PRD or product requirements document to essentially show our AI coding tool, which will be Cursor in our case, what this application will look like. So this PRD should have core features as well as the tech stack of your application and then a step-by-step implementation guide. So for us here, I just simply told ChatGPT we're creating a Next.js project where users can upload and browse recipes. Now this will be a recipe sharing platform. We'll just want a PRD that has features, a tech stack, and a step-by-step implementation guide. And just so the AI knows, we will want to use Supabase for the database and authentication backend. And then as we can see here, the core features will be that users are able to sign up, log in, and log out using Supabase to access our application. They'll also be able to reset their password. So those are some pretty standard functionalities. Next, for recipe management, which is the core product of the application, users will be able to upload recipes with details like titles, ingredients, steps, and an optional image. Users can also browse all uploaded recipes, and even view a detailed page for each recipe. We'll also want to add some search and filtering. And lastly, we just want a responsive design to make sure that the platform is mobile friendly. Now let's begin and start creating our project and starting with a Next.js project. So what we want to do is first head over into our computer's terminal. So what I've done is inside my Mac, I've created a blank project called Cursor Projects 1. So what we want to do is first direct into that folder. So cd is the command inside your terminal. And then you just want to go to cursor dash projects dash one. And obviously this will be the name of the blank folder that you create, but in my case, mine is called cursor projects one. So now that we're inside this folder, what we want to do is just create a new blank Next.js application inside this folder. So from here, all we want to do is run this command. So it's npx create next app at latest. So what this means is that it creates a Next.js project inside this blank cursor projects one folder. And for us, it'll install the latest version of Next.js, which is Next.js 15. So if you're watching this tutorial a few years down the line, then it might be even on to like Next.js 18. So just make sure that everything is updated to that specific routing. But for now, everything should be the latest. So from here, let's go ahead and run this. Simply press enter. You'll be greeted with some settings that you can enter in for your project. So for us, we want to create a recipe sharing platform. So let's call this recipe sharing platform. And then a key thing here is to make sure that your file names never have spaces and they're properly formatted. So for myself, I usually just keep things lowercase with dashes. And then let's go ahead and enter this. And like I mentioned in our previous modules, we'll want to use TypeScript since this is a more safe version of typing within JavaScript. So let's click yes here. For ESLint, this will just make sure that if there's any syntax errors inside your code, it'll underscore and underline them red. So you'll know when there's issues inside your code base before even deploying. So this will be helpful. Tailwind CSS. Like I mentioned, these are default CSS classes that we can reference. So rather than defining every single possible CSS class, so one for H1 tags, one for body paragraphs, you can just simply reference all of the default ones within Tailwind. So we'll want this. We don't need the src folder directory. I find that especially now in 2025, it's a bit easier to just keep everything inside our app folder. So we'll do the same here. So let's click no. For app router, yes, this will be the core component of Next.js that allows us to build in full stack. For TurboPack, we don't need this, so we'll click no. For import alias, this is just for shortcuts. We also don't need that. So let's go ahead and install all these dependencies. And following this, we should now have a default Next.js project inside our cursor projects folder, and we can begin to start working on it and start building out our recipe sharing platform. Now I've gone ahead and just hopped into our cursor project that we just made. And now just to show you guys a little quick something, I've gone into the settings here and I've just added some rules for AI. So these are essentially rules that get shown to AI with every single prompt you send them. So I briefly covered this in the previous app builds, but you can just go ahead and copy and paste these rules if you want to. Plus there's a ton of different cursor rules. You can just go to cursor.directory, but I've gone ahead and pasted in rules that are specifically for TypeScript projects with Next.js, App Router, React, as well as Supabase. So from here, you can see all of the different backend processes that are happening. So we have request analyses, solution planning, etc. These are just general best practices for Next.js projects. But again, as long as you have some semblance of this, then you should be fine. You just want to make sure that the app isn't changing from Next.js to a possible different framework and that it knows that you're using TypeScript in all of your files. So this is just something that's kind of important to keep around. But for now, we'll just exit out of this. And as you can see, we have a blank Next.js project with our app folder. So no source folder, everything will kind of be contained within this app folder. And this is just the default Next.js settings. So now let's go ahead and implement our application. Let's now work on creating our actual app. So to start, we want to just open up the Cursor Composer window. So to do this, you can just simply click Command L and it pulls up either the chat or the composer. So like I mentioned in the previous sections, the chat essentially mimics what you would use in chatgpt.com or Claude. It's a simple chatbot, but if you use Composer, which is Cursor's feature, it gives the LLM model the actual code base for your project so that it can constantly reference what files you have in your code base and what to change in your project as a whole. So for our project here, let's go ahead and stick with this Composer feature. And what we want to do is just have this Cursor platform create the project for us. So we can first say, please create a recipe sharing platform for us. And then to start, let's go ahead and paste over the PRD that we created in ChatGPT. So we can say PRD below. And this just gives you, once again, all the details of our application. And then just as a final kind of note, we'll say, please only update the home page UI for now. We want a simple design. And then after this, we can begin implementing Supabase. So again, like I mentioned in the previous sections, what we want to do is just create a very basic initial draft of our design. And then once we're happy with this, we can begin actually working on connecting this front end to the back end through the use of Supabase. So from here, the last thing we'll want to say is that we are not using a SRC folder. These are just one of the settings that we kind of typed in during the NextJS project setup. So now with this, we can click enter and cursor will now work its magic. So the first thing they're doing is creating the header component, which if you remember what I said in the previous sections, these are just reusable components. So we'll edit all of the header sections here. And then for our actual page.tsx file, which is our main landing page, it'll reference this header import and import it into this file. So now we can see this is a very standard header component. Scrolling down, we have our home page. It's importing the header. And then we can see this will create a clean modern homepage with the header, with navigation links, a hero section, and then a featured recipe section with placeholder cards. So now let's go ahead and accept this all. And to run our application, what we can simply do is bring up the terminal here, and it automatically directs us to our project folder. So we can simply click npm run dev and go to our localhost URL to view our application. So let's wait for this development server to run. As we can see, we have our localhost URL. So now let's copy this and follow the link inside an incognito tab. Now you can follow along and just do this in any tab you'd like, but I prefer incognito just so no browser extensions will essentially mess up how your app will look on the front end. Great, and as you can see, we have our landing page created. So we have our header component here. Like I mentioned, this is not part of the page.tsx file. This is the page.tsx file. We're simply importing this header component, but this just takes us to our main page. This should be 404 errors because once again, we haven't created any of the login or sign up pages yet. We need to implement Supabase for the backend. This should also go to a 404. So for now, this is what our app looks like. This is just kind of like a main landing page. We have featured recipes below for people to upload recipes into our marketplace. And for now, let's begin working on the back end of the application. Now, before we do anything within Cursor, we need to first create our Supabase account and their associated project because like I mentioned, we'll be using Supabase as a backend. Supabase will essentially simplify everything for us and will handle authentication for users as well as handle all the data in our database. So to start, what you want to do is first create a Supabase account. So right here, I'm logged into my AI Code Pathways Supabase account. But for you, you'll probably be prompted to either sign in with GitHub or create a new account through an email. So after you do so, what you first want to do is now create a project. So this new project will essentially tie to the Cursor project you're creating. So click new project. We'll choose our organization. And then for our project name, let's just go ahead and name this the exact same name we have inside our Cursor project. So we'll call this recipe sharing platform. And then below this, you'll just want a database password and make sure this is secure so that only you have access to this database password. So for me, I'll just type something in. Great. And then below this, we have the region. So in this region section, all you want to do is select the region that's closest to your users of your application. So here you can see all the different regions. Obviously, if you're US based, I would choose North Carolina, North Virginia, or Ohio. For me, I'm in Southern California, so I'll choose this as the closest region for us. But again, this is based on users, not you yourself. So if you think your users will all be coming from Canada, but you yourself reside in America, then I would select Canada there. This just makes for a better user experience, faster loading times, and just optimizes everything on your app. So from there, you can now create your project and wait for this to load. Great. And then now it's setting up your project. So it's important to not really do anything until this project actually gets set up so that you can begin setting up authentication as well as your database. So just give this a second and wait for the setting up project to finalize loading. Great, so this usually takes a couple minutes, but now that your recipe sharing platform project is created, we have the option to do a few things. Now, before we continue, let me just preface this by saying that you'll mainly use Supabase for 3 things. The first is authentication, the second is storage, and the third is database. So authentication you can think of as users. For the database, this is where users can store their own data and they can create new data inside your application. And then storage will mainly be for storing files inside your app. So for example, if you have users and you want the users to be able to upload some profile images of themselves, the file images and the file URLs of those images will be inside storage. So data you can think of as just data documents. These can be text, strings, numbers, booleans, even arrays. But if you want to actually upload files, so images or multi-file uploads, you would need the storage section here. So that's the 3 main use cases we'll need. So for now, let's just go ahead and first head over into authentication. And just one thing to note is that with Supabase, this really simplifies things compared to if you're using your own authentication provider like NextAuth or NextJS. And our goal here, obviously with AI coding, is to really simplify kind of the like pain points between what makes a real developer and what they spend time on versus how you can quickly just get your project up and running without needing all the technical know-how. So this is where Supabase really fills the gap here. And to start, we just want to make sure that our authentication providers are set up. So within this authentication section, we'll be able to see all the users that have signed up to our project, but this is only after we connected our Cursor Next.js project with Supabase. So for now, there's obviously no users in our project, but one thing we can check off just for settings is to first head over into providers. So for now, we only have email enabled. So what this means is that if you head over into any website, even Supabase, for example, when you sign up for an account, it asks you for an email and password. This is what the email auth provider is. But sometimes if you head over to another website, say if you go to notion.com, you can log in with your Google account for Notion. So this is this Google auth provider. So you can choose to authorize users using either email or any of these social platforms. So basically, if you're running a SaaS application and you want the easiest way to onboard users, you would have email checked off since this is the most standard, but you may also have phone. So users can sign up for your application using a phone number. You can also have Apple ID. You can also have Facebook, also have Google. So you can basically enable all of these. All it takes is just one click. But for now, for our application here, since this is for demonstration purposes, we'll just keep this for email for now. But the process remains exactly the same, depending on whichever auth provider you choose. I would just recommend, though, that you don't do something a bit more niche like KakaoTalk unless you're dealing with more Asian countries, or Slack unless you're dealing with Workplace. So for now, we'll just keep this at email. But an important thing to note, especially when you're testing out your application for email, is that you want to turn this confirm email off. So what this means is that right now, once a user signs up for your platform, they won't be able to log in until they confirm their email address. Now, this is obviously for security and safety concerns, but for us, this is just more of a hindrance than anything because we want to be able to log into our application immediately, especially if we're using test emails that we don't have the actual email access to. So for us, we can just turn this email off and then save. So this way, when a user signs up for our application, so we can do testuser@gmail.com, we don't actually need to log into testuser@gmail.com, click a confirm email before logging in. So this just removes one extra step for us. Let's click save here. Great. And then as I mentioned, if you do want to add any other auth provider, you can simply click into any of these and then enable them. But for now, we'll just stick with email just to show you the basic concepts of how to get users to sign up for your application. And then lastly, you want to head over into URL configuration. Now this should already default to localhost 3000, which should be your local URL. But when you deploy your application, so what I mean by this is if you buy your own domain, so for example, if you're creating an app called W3, And then, or better yet, let's just use recipe sharing platform. So let's say we call a recipe sharing platform rsp.com. We would change this site URL to rsp.com. But since we're only testing out this project inside our local development server, this localhost 3000, we'll keep this be and let it be. But I would just keep this in the back of your head once you actually do deploy your app, since you want to change this site URL to your actual production URL. Now let's start moving on to the more exciting part of developing with Supabase in NextJS. And the key part here is developing your database. So like I mentioned, for every single application with backend, you'll need a database. And inside this database, this is where users will create, read, update, and delete documents. And you can think of documents as data. So for our application here, we'll probably have two data tables. The first is for profiles, and the second is for recipes. So obviously every profile can upload a recipe, and then every recipe data collection has multiple different fields. So this is where we can have AI actually brainstorm with us and provide us with the data tables we need to create within Supabase. So the workflow here is first have AI understand your project, which we did with the PRD. And now that it understands your project, it can advise you on which data collections you need for your application. And you would then take those data tables and data collections into the Supabase website. And inside the Supabase dashboard, you can create the data tables that you need for your project. So for us here, like I mentioned, we want to just kind of figure out the data tables we need. So we'll say we just created a Supabase project and enabled authentication or email only. Can you help us with the database table setup? So now let's see what AI recommends for our data tables. And we can see that it's provided a few tables for us to use. But just to show you how everything works, let's first head back and read these. So the first table it wants us to create is categories table, recipes table, initial categories, and triggers. But for now, let's go ahead and just simplify this a bit just to show you how everything works. So we'll say, rather than doing those, can you create only two tables to start, no categories, just to show you how this works initially before we start creating tons of tables. So the first is a profiles table with ID, username, full name. Second is the recipes table with ID created at, user ID, title, ingredients, instructions, cooking time, difficulty, category. So rather than doing categories as its own separate data table, we can just have this inside this recipe section here. Now what I'm doing is just essentially recommending to AI what I think the best data collection set is here. Now obviously there's no wrong way to go about this, but I think this will be easier to showcase how everything works. And just so I understand everything, let me just read over this one more time to make sure we're not missing. So we have our username. Let's also include created at and updated at. So this just shows you when profiles were created, when they were updated. And then for the recipes, that looks good. So now let's wait for AI to provide something. Perfect. So now what we have are our two data tables. So what they're doing is returning SQL functions or SQL functions to us for us to just type in directly for Supabase. So I'll show you how to do both of these one by one. So let's first head over to Supabase and start running some of these commands. So now I've gone ahead and just copied and pasted a screenshot of what Cursor provided us for data tables. And I also simplified the tables a bit just so you can understand what's happening at a more macro level. So to start, we can see that it's first having us create profile tables. So like I mentioned, there's going to be two main data tables inside our project. The first is profiles and the second one is recipes. So the profiles will create the recipes, whereas the recipes will show details such as ingredients, time used, as well as steps to actually create the product. So let's start with one data table at a time. So the first one to start with here will be profiles. So as you can see, the AI has basically provided us with SQL functions. So rather than doing this directly within Supabase, we can literally just copy and paste these SQL functions into Supabase and have it be done. But just so you know how everything is working here, let me pull this off to the side. So the first thing is to create table profiles. So we can see it says create table profiles. So rather than running this, if we wanted to, we can go to SQL editor and just paste in the code. But Supabase works in a very simplified fashion. So you can think of this as a visual builder, and you can actually just do this without writing a single line of code. So what you want to do is just head over into the database. Right now, if we go to tables, we don't have any tables. That's why our schema visualizer is completely blank. But if we wanted to create a table, all we would have to do is click new table, and then we can call this what they called it here. So profiles. Let's type this in. Great. And then next, we have a description. We'll just leave this blank for the time being. And we can see that they want to enable RLS, which is row level security. This just makes sure that profiles aren't able to do wonky things with other profiles. And this actually makes the profiles private so that public users can't just see everyone's profile or profile data. So this is why we want to always make sure that row level security is enabled when we're working within the database. So right now we want to create a table called profiles, and then all of these fields below here are the actual fields within our profiles. So you can think of these as columns. So let's first accept this, cancel, and then let's create all of the columns needed. So let me just quickly type these in and pull this off to the side. So the first column is called ID, and the type is UUID, which is just the unique ID. So scrolling down here, we have universally unique ID. And then the default value, let's actually change this because we want this to reference our authenticated users. So the AI, once again, has done this for us. We can see that ID references authenticated users ID. So what this means, and lastly, it's a primary key. So this is why we checked primary key. But because it references authorized users ID, what this means is that the ID inside our profiles will connect to our authorized users. So authentication and database are two different things. So a user can't sign up for our application, so they're an authenticated user, but to create a profile is completely separate. So that's why we need to connect the two with this one single ID. So pulling this back off to the side, the way we would do this is first click here, and then we want to link this with a foreign key. So the schema that we want to select here is authentication, and then we want to authenticate our ID of the users. So let's find auth ID users, perfect. And then the public profile is ID 2, and then we want the ID of the users. Great, let's click save. And let's remove this default value, perfect. And then now as we move along here, the next one is username. So it's text, it's unique, and it's not null. So these are the three describers of the username. So let me just show you how to do this. And once again, you can just copy and paste this code directly into SQL, but I'm just showing you what's happening behind the scenes so you understand once you build your app yourself, or if you do get stuck when it provides you the incorrect SQL code, which could happen. So from here, we'll type in the second one, which is username. This will be of type text because again, usernames are only text. And then for our default value, let's first change these settings. So is nullable means that it can be 0, but for all of our profiles, they need to have a username, so it should not be nullable. And also it shouldn't be unique because again, a username can be, or it should be unique because again, we don't want two users to have the same username. So we'll check is unique, but not nullable. So again, is nullable means that you can have nothing in the field. So when a user signs up for a profile, if they ask for a username and they don't put anything, we will reject their response because we didn't check is nullable. So that's all that means. Great. And then let's go ahead and add some more columns. So the next one here is full name. And then we want this to be of type text. And again, this, nope. We want users to implement their full name, but this doesn't have to be unique, because again, some users like John Smith could have the same exact name. So that's why we want to keep is unique to be checked off. Next is the created at and then updated at. So here, let's just type in created at, and this will be time zones. Great. And then we want this to not be nullable because again, we want to know when the profile was created. And then for our default value, this is where we actually want to set a default value. So returns the current date and time. So this is when the profile was created. And then lastly, we have updated at. And then this will also be a timestamp. And then the default value for this will also be now, just so we know when the profile was updated. And once again, it's not nullable. We need values for all of these. And especially for username, we need to make sure this is unique. So none of these fields are nullable, which means a user has to provide all of these fields when signing up their profile. So now let's click save. And this table is now loading. So we've successfully created the profiles table. And then lastly, like I mentioned, we need to now enable RLS, which is row level security. So I already enabled this in the settings of the table. So if we go to edit table here, you can see enable RLS is on. But now what we need to do is actually set the RLS policies. So to do this, we would once again go to Authentication. Then we go to policies. So these are where you set your RLS policies, and this will show all of the data tables that you have. So right now we have a profiles data table, and we also need a recipes data table, which we'll create later. So for now, let's click create policy. And as we can see from my screenshot, we have 3 different policies. The first is a create public profiles are viewable by everyone. So this is select. So anyone can select public profiles. Insert means that any user can create their own profiles, and then update means that users can update their own profile. So 3 main RLS policies. First one we'll do is profiles are viewable by everyone. And again, these are just the RLS policies that AI provided us for our project. Next table, we'll keep this to be public. Policy behavior, we'll keep this to be permissive. And then the first one here, like I mentioned, is select. So now we want to choose select. Great. And then using will be true. And we're getting this value just from here, it says true. So again, you can just simply copy and paste this code, but showing you how to do this just so you understand the back end. Next, we'll create the second policy. This one will now be called insert. And then we'll call this one users can create their own profile. And as you can see, if you change between these, it's actually updating the row level security policy for you. So for this insert, we just want to copy and paste this auth ID, and this will be a SQL expression. Save policy. To add this. Let's make sure I'm copying this right. Auth.uid equals ID. And let's now save the SQL policy. Great. And then lastly is a update. So once again, create a policy. Let's do update. And then we'll call this users can update their own profile. Great. Policy command is update. Target roles, default. We want to make sure this is always default. And then for update, it's using true. And with check, we once again want to use this auth.uid equals ID. And let's save this policy. Awesome. And then now we can actually visualize how our table looks. So heading back into our table editor, let's go to our schema visualizer. So now this is what our data table for profiles looks like. So we have ID, which is the primary key, and it's tied to auth users. So that means that when a user authenticates, there's a unique ID for the authenticated user and it ties immediately to this profile. So this is how we connect authenticated users to their actual profile inside the application. And then the other required fields are username, full name, when the profile was created, and when the profile was updated. So now let's move on to the second data table. Now I've gone ahead and just asked Cursor to provide us with the SQL commands for the recipes table. So I just said, can you provide SQL commands for the recipes data table now? So we have all of the categories here, as well as all of the basic security policies. So essentially the same as before, but now what we have are recipes. So these are basically all the fields of the recipes. So you have the ID of the recipe, when the recipe was created, user ID of the person that created the recipe, which will once again reference the authenticated user. Next is the title of the recipe, description, ingredients, cooking times, difficulty, category, and instructions. And then once again, we have our basic CRUD RLS policies to either create, read, update, or delete documents. So these are all of the basic policies that are usually set up for most basic CRUD applications. And now let's go ahead and rather than doing all of the visual learning we did inside the profiles data table, now we can just simply copy and paste this SQL code. So what I can do is first copy over this create table just to show you how this works. Copy this and then head back into our Supabase. So from here, let's now go to our SQL editor and paste this in, and then we can just click run command. It says success, no rows returned, meaning that all of these rows were run. So now if we go to our table editor, our database and our schema visualizers, we can see it automatically created our recipes for us. So we basically just took the long way with these profiles, but for our recipes here, we just denoted that we only wanted the SQL commands. You just type those in. It's just good to always double check to make sure auth user's ID is connected to user ID. And just to make sure that everything is correct, you can also check this legend down here below. It's schema visualizer. This just helps you visualize your data tables. So right now, the ID of the recipes is the primary key. Everything is non-nullable, meaning you have to have a value for everything except for the description, cooking time, and difficulty. So this means that every recipe has an ID, which is correct. Every recipe has a created at time. Again, that's correct. Every recipe has a user ID that's assigned to that recipe. So you can think of this as the creator of the recipe. This is especially important because the user ID of the recipe is the one that's able to edit the recipe as well and delete the recipe. We don't want any user that signs up for our app to be able to edit or delete recipes. We only want the original user to be able to do so. So that's why we have this key relation here. And again, this is what the AI kind of denoted us to do. Next is title, description, ingredients, cooking time, difficulty, etc., etc. And again, black diamonds just mean that these all have a value. And then following this, the last thing we'll need to do is just copy and paste the RLS commands. So we'll do this one at a time. First is enable RLS. So let's head there. Great. And then let's now head into our SQL editor once again. Delete this. Alter tables, recipes. We want to enable RLS. Run. Success. Great. We can delete this. All this does is enable RLS security for that table we just created. And then next, we just want to set up basic security policies. So again, these are all the basic security policies for a CRUD app. So now let's head back into Supabase, run this. Recipes are viewable by everyone. So this means everyone in our application can view the recipes. Head back to Cursor, copy this. And Cursor just makes this really easy because again, you don't need to actually do anything much. You just have to run these SQL codes, head back into SQL, delete this, run this. Users can insert their own recipes. So this means that any user can create their own recipe and they'll be essentially tied to that recipe. That's why there's a check. The auth ID equals the user ID of the recipe. So this is what's happening here. And I'm doing this one at a time just in case there's any errors. If we just run like 50 SQL lines, there could be a typo somewhere. So this is why we're just doing it one by one to make sure there's a success. Great. Heading back into Cursor, we just have two more policies. So once again, copy head back into Supabase and paste this in, run, success, and lastly, users can delete their own recipes. So again, this update and delete recipe, let me just show you real quick once we head back into SQL. So for update and delete, they're once again checking that the authenticated user matches the user ID for the recipe so that only that user that created the recipe can delete or update the recipe. So delete, same thing. Let's run, success. And just to show you that everything is working and how we kind of took a shortcut, if we go to authentication, policies, we can see that for our recipes table now, we have all 4 of our RLS policies. And these 3 we just created directly within the Supabase dashboard. So this is just a quick way to just use SQL to essentially format your data tables. And again, if you're lost on whichever app you're starting, just easily ask Cursor which data tables you want to have in your application. So ask them what the best process is. They'll provide you with all of these SQL lines. And you can denote if you want a simple or a complex database structure. For now, we're keeping it a bit simple just to show you how everything works. Great. Now that we've finished setting up all of the backend data tables within Supabase, we can now return back to Cursor and begin actually implementing Supabase into our project. Now, before we do this, the first thing I want to just quickly do is to first have Cursor confirm that it knows our data tables in the backend so that when Cursor actually edits our files, they'll know how our data table is structured. So the way I did this is I just pasted in an image of what our current data table schema looks like. So these are just all of the different types of categories we have. So we have a table, and I've included all the rows as well as all of the different RLS policies. And again, this is just everything that we've implemented in the past videos. This is just a reminder for the AI to know. So we'll say that we have finished creating the 2 data tables in Supabase, profiles and recipes. Please reference this image so you know what fields we have in each of the 2 data tables. Now let's go ahead and from here we can start the initial setup of Supabase in this project. Please walk me through this. Great. So now let's wait for the AI to provide a response. So first, as you can see, we have some dependencies for Supabase, and then we'll need to update types in our database, as well as create a Supabase client utility, create a .env file, and I'll show you what you need to do here. So this is the kind of section where you actually need to provide your own URL keys from your Supabase account. So this will need to fill in. The middleware will also be handling authentication with users, so that'll be fine. Next, we'll need to update our root layout, create a server-side Supabase client utility, and then we'll have the basic Supabase setup complete. So to first do this, let's tackle this one by one. So what we'll first want to do is install the required dependencies. So let's copy this inside our root folder here. We'll run this npm install. Let's wait for this to load. Great. It's installed packages for us so that we can now use the Supabase client. Next, we want to create a type files for our database. All this does is essentially show the 2 different types of data tables we have. Now, before we just accept this change, let's just make sure that this matches up what we created in the backend with Supabase, because if it doesn't, it'll then cause some client errors when we run the application. So we can see the profile has an ID, a username, full name, created at, updated at, email, and bio. Perfect. Next, we have the recipe, which has the ID, created at, user ID, title, description, ingredients, cooking time, difficulty, category, and instruction. And the data type all looks correct as well. So these should all be strings. Great. Next, we have the Supabase client. So let's first accept this change. Moving on here, we have the Supabase client utility. This is just to help connect Supabase into our project. So this is all pretty standard. We'll accept this. Next is the .env local file. We'll accept this, but we need to populate this with our own URL keys. So I'll show you how you guys actually find that. So we'll hold off on that. Next, we have a middleware file to handle authentication. Again, this will just handle users. This is pretty much boilerplate code that you'll use in every single one of your projects with Supabase. And then following that, we're updating our root layout to include the Supabase provider. Again, pretty standard. Server-side Supabase client utility. And then finally, we'll have the basic Supabase setup complete. So let's just accept all. And as you can see here, they've also added a test for us in the header. So this will show auth state, and we can actually test this ourselves to see if the auth state is working. But let's first paste over our .env local file keys, just so we know how everything is referencing one another, because we need these .env local keys to actually connect this cursor project to the Supabase project that we created on the Supabase dashboard. So heading back over into our Supabase dashboard, if we scroll down here inside the home section, we'll have two API keys, which connects this Supabase dashboard project to our actual cursor NextJS project. So what we want to do is first copy over our project URL and then head back into cursor. So let's come here. We'll go to our .env local file that was just created. And as you can see here, we'll have two different fields to update. So the first is the project URL. So let's just now paste the project URL in. And then next is the API key right below. So let's copy that once more, head back over into cursor inside the env local file, and let's paste in this key. Great. So now let's go ahead and save everything to make sure that everything is running. And we can also add a git commit here. So we'll just type in initial Supabase client, and let's do a commit. Yes. So this will make sure that we have all our changes saved thus far. We've only had one commit since, which is just the initial commit of creating the Next.js app. So now let's go ahead and test out our application to see if everything is working. And before we actually go to our development server, let's just have cursor kind of make sure that we are connected to Supabase by writing in a quick test. So what we can do here is just type in, we have populated the .env file inside our code base. This way they'll have access to our code base. And we can just say, can you just implement a quick test on our homepage to make sure we are connected to Supabase. Great. So now they'll test the Supabase connection, and we'll generally want to just do these tests after each major change to make sure that we're not spinning our wheels and that everything we did basically cause some major change in our application. So for example, if we didn't test this and we kept on continuing with our application, we wouldn't even know if we were connected to Supabase until we got multiple error messages. So this way you can know, like, at every step along the way of your application, everything works before you move on to the next step. So from here, let's accept this change. We don't need to review this too much because this is just going to display basic data about whether or not our connection is accurate with Supabase. So from here, let's do npm run dev. Great. And then let's head into our recipe sharing platform. Let's reload this and wait for this to repopulate. Perfect. So this is the component that Cursor added for us. So this is a Supabase connection test. And all this is telling us is that we're connected to Supabase in this project. So this doesn't mean that we've added any data into our database or authenticated any users. All this means is that we're successfully connected to Supabase. So this is what this successful message is. And this just confirms that everything we did to initialize Supabase in this code is working properly. So now we can begin actually adding in users and adding in data and start testing out that functionality. And the reason why we found 0 profiles is, again, because we don't actually have anything in the database or any users inside our Supabase project. We'll need to actually authenticate them ourselves or add them ourselves. So let's now head over into doing that in our next section. Now that we've confirmed that the Supabase is essentially connected to our Cursor project, We can now remove, first off, the Supabase test. So let's first say, please remove the error message from our UI, confirming that everything is connected properly. This will just make sure that our main page of the app no longer shows the test. So this will just essentially remove the connection. So let's wait for this to now update. It'll just remove some of the queries. Perfect. Awesome. So let's accept this change. And then now what we can do is begin working on auth. So let's now start working on auth components / files, because now we're able to either sign up or log in users since we've confirmed that everything is connected. So the first thing we want to create is a reusable auth form component. So this is how users will sign up for our application. Next, we'll have a login page. Let's wait for this to load. And then a sign up page. Great. So as we can see, these are going to be separate login and sign up pages. So again, recall again from our previous modules, all we're doing is editing this page.tsx file. We'll need individual URL routes for login and sign up. And what they're doing is actually importing our auth form, which we have inside our components folder. So now we have a header and then this auth form. Perfect. So the reusable auth form handles both login and sign up, has error handling and loading states, which is perfect for us, just for UI. Has a proper form validation, responsive design. That's all fine. Client-side routing. Great. So let's now go ahead and test that this actually works. So let's first accept all and say we would like to now test the authentication flow. And this will just help Cursor know that we're going to essentially try it. So we have to first sign up and then log in. So as you can see, we don't actually have a button to direct us to the sign up yet. So this is why we need to manually go to this URL, sign up, and then after we verify that sign up works, we'll then go to log in to make sure that we can log into our profile. So let's go ahead and test this out on the UI of our application. So from here, I'll go ahead and run npm run dev. And let's wait for this to load. Now let's go ahead and test out our application. So I've gone ahead and reloaded our localhost URL from here. You can see that it's loading. Just make sure everything's working. Great. So this is the latest version of our application. And just to show you that we currently have no users inside our authentication. Right now I'm inside our project. So AI code pathways, recipe sharing platform. Right now, we don't have any users under authentication. So now, once we sign up users, we should be able to see them inside our Supabase backend. So to test this out, let's first go to sign up. And let's just try this with a test user. So we'll do testuser@gmail.com. And then the password should be test user. So now once we sign up, it should automatically redirect us to the home page. But first, it may redirect us to the login page just because we need to confirm our email. Let's first click sign up. Great. So this is now the login page. As we can see, for the routing, it's the login. So now let's do testuser@gmail.com. And then for the password, we'll also do test user. So that's what we set it to. And perfect. Now we're inside the same exact site. So right here, we can see we're just in localhost 3000. Nothing has changed in the URL, but now we have what seems to be a dashboard button, which shouldn't take us anywhere yet because we haven't created a dashboard. So heading back, we have a dashboard and we also have a sign out button. So this means that we're properly signed in as test user. It's recognizing this in the header. And now if we click sign out, we should no longer be logged in. And as we can see, we have the option to log in or sign up another user. And just to test this out, let's do testuser2@gmail.com. And just to test out that we have error handling as well, let's just do test user and do a 2-letter password. It should reject both of these. So let's click sign up. Great. So now it's saying that we need a proper email, which is what we want. So testuser2@gmail.com with a 2-letter password. Let's try to sign this up. Great. There's also secure passwords just to make sure everyone's data is a bit more safe on your app. So now we'll just do test user 2 as well for the password. Click sign up. And then once again, we're redirected to the login page. So let's do testuser2@gmail.com, test user 2. And the reason why it's redirecting us to the login page is because for best practices, you should first confirm your email before logging back into the app. This is what most apps do. We just turned this off because we're using test emails, and I would have to create multiple emails just to be able to confirm and actually head into the app. So that's the reason why this is the workflow. But for now, let's just log in. And great, we have two users now, test user and test user 2. And to sign out, let's just click sign out. And then the last thing to check is inside Supabase, we should now see both these users. Perfect. So we have a test user and then a test user 2. Great. And we can see they were created during this time. And we can also see when they were last signed in as well. As you can see, we can see their emails, test user and test user 2. So this means that our authentication is properly connected to our Supabase backend. So now that we've confirmed that signing up users and logging in users works, this wraps up the end of the authentication section. So our app is now full stack with authentication capabilities for users. So now what we want to do is begin building out our app more and start working with the data tables that we created within Supabase. So if you recall here, we now want to connect our application to be able to first have profiles and then have profiles to create recipes inside our complex app. So to start, what I want to do is just redesign this landing page a bit because again, these are all just placeholders. So in my head, it makes sense for our application to only have like kind of a main page that says sign up or log in. So you wouldn't have any featured recipes. These would only show up after you log in and go to the dashboard. So what we can do is head back into Cursor, simplify this main landing page until a user signs up. And once they sign up, they can then be redirected to either a more detailed homepage or just directly into the dashboard. So now let's begin by editing our homepage. So we can tell Cursor, we have confirmed that authentication works. We now want to start building out the app. To start, we want to remove the featured recipes section in the homepage. And this way, Cursor can remove this section for us. They'll simplify the homepage by removing the featured recipes section. So let's wait for this to be applied. We can see all they're doing is getting rid of this div container that has the recipes section. It's very easy to fix. Let's accept this. And then following this, we'll say that we first will be nice to the AI, say thanks. We want the homepage to just be a sign up /login section. So can you link the start creating button to a sign up to the same sign up form? And this just ensures that if you're not logged in or signed up as a user, all of the buttons on the homepage will essentially prompt you to create a profile inside our application. So let's accept this. Let's just first make sure everything is correct. So they're creating the button link, and the href is going to the sign up page, which is perfect. Class name, it's keeping the button classes. So let's accept this. And then finally, we can begin working on implementing the dashboard. Now that they've created our simplified homepage for us, we can now create the second dashboard page where users get redirected to after they log into the app. So for this, we can say, can you now create a dashboard section where users get redirected to after logging in? This will be a simple dashboard that shows recipes uploaded by other users. Great. And then now it'll go ahead and create a dashboard page that displays recipes, and it'll have recipe card components where if you click into the component, you'll be able to see details of the recipes. So let's first have the AI essentially create out a structure for us so we can see how everything looks. And once again, we'll always just want to review all the changes the AI is making. So to start, they're creating a dashboard page that displays recipes. Now, before they create the dashboard page, recall again that we need to create the components and then import the components. So this is what the recipe card looks like. They're importing the recipes from our database. Perfect. This is of type recipe card props. We can see it's exporting all the different styling of what our recipe should look like. That looks good. Next, we have the dashboard page. So let me head back here. We have the dashboard page that imports the header. So we'll want the header once again, Supabase client, recipe card, redirect for navigation. Great. And then moving on, we'll also have the auth form redirect to the dashboard after login. So this all looks good. Let's click accept all, and then let's test out our application to kind of confirm that everything is working in regards to navigation, in regards to being able to only access the dashboard after logging in. So I'll see you guys there. But now, as we can see, we're inside the homepage here. So we can either log in, sign up, or click start sharing, which should be the sign up button. So let's try signing up a new user by clicking this. And then for a new account, we'll do testuser7@gmail.com. And the password will be testuser7. Let's click sign up. And we can see that we're now taken to a dashboard. As you can see, it's localhost 3000/dashboard. And this is where we'll be able to add recipes. And if you are signed in, it'll automatically take you to the dashboard rather than just the home landing page. So now if we were to try to go home, it would always redirect us to the dashboard since we no longer have any need to actually go back to that landing page. And then if we sign out once again, it'll take us back to this landing page where we're once again prompted to sign up for the application, confirming that everything does work in this kind of flow, just to make sure that users will be able to authenticate. And once they do, they can start adding recipes. Let's now start by adding some functionality to the databases that we created within Supabase. So if you recall, we created a profiles database as well as a recipes database. So now authenticated users can update the profile with their full name, a bio, as well as all the recipes they've created. And then we'll also have a recipes database that just shows all the different recipes that users and profiles have submitted. So to start by linking these to our application in Cursor, I've gone ahead and just pasted in once again the data table schema just so Cursor remembers what we created in the Supabase backend. So now let's say we want to begin linking our data tables to the web app. We can ask them which one they recommend to start. I would always generally do this if you don't know which direction you want to go within the build. So we can say, do you recommend working on user profiles first and then adding recipe functionality, or vice versa? And let's see what they respond with. And as we can see, they're recommending us to create user profiles first because of the logical data flow. So right now, recipes are linked to users. So if we made recipes first, they wouldn't link back to user profiles. They would just link to actual users. So in the authentication context, you already have authentication set up. So extending it to include user profiles would be the next step. Great. So what we can do is they're first having us update the database types to be user profiles. Now this is important because we want to make sure this matches what we have inside our Supabase. So we have an ID, that's correct, string. We have username, full name, email, bio, created at, and updated at. So those are all correct. Next, we have our profile creation on sign up. And again, just so I can touch on this, these are what we created at supabase.com in their dashboard. We just want to make sure this links up to what we created. But moving on, we have the profile creation on sign up. So what this means is that once users sign up, they'll be able to create the profiles. So from here, let's go ahead and accept all. And let's test this out inside our application. So now let's test this out by trying to sign up a new user. So let's go ahead and click sign up. And then we'll do testuser8@gmail.com. And for the password, we'll do testuser8, sign up. And we can see that we are signed in as testuser8, but there's an error on the UI. So what we can do is just go ahead and copy and paste this authentication error from the console directly to Cursor and have them debug this error for us. So now heading back into Cursor, let's say we implemented these changes, but on our app console, we received the error below when signing up a new user. And then let's have Cursor now provide a solution for us to move forward. We can say that they want to improve the error handling by adding more detailed logging to see exactly where the error is occurring. So this is what I mentioned in the other section as well. This just kind of adds a couple more steps into error logging just to see where this is exactly failing. So let's go ahead and click accept all. And then now test this out once more. And before we continue, we just have to reiterate this. So I just gone ahead and checked the profiles tab in our Supabase database. And from what I've seen, everything is non-nullable except for the bio. So we'll just clarify this with cursor here. So we'll say everything is correct for columns, but all the columns are not nullable except for bio. So username, full name is nullable, is not nullable. And that means we have to have a username and full name. So let's see if this updates anything within the code. So we can see they're updating the database schema. So that's just one example. If this does fix the error, it's just simply because our Supabase database didn't exactly match what we have here. So let's click accept all. And now let's test out our application once more. So now heading back into our application, let's go ahead and sign up a new user. And this will be called testuser9@gmail.com. Testuser9, click sign up. And it's taken us to the dashboard, but we still want to be able to edit our profile. So once again, let's head back into cursor. But just one quick thing to note here is that this profiles is actually working. So what I mean by this is inside Supabase right now, if we head over into our database and then we go to tables and under profiles, we can see that we actually have a row created. So let's view this in the table editor. So we can see that when we signed up a new user, it automatically created a profile. So they set the username to just be the username. And then the full name they set to be the same exact thing, which is username. And then the bio is null because there's no option to select the bio when you sign up. So what we can do in terms of next steps is either have all this information be editable fields initially, but this isn't the best user experience because again, you don't want to think about creating a bio as well as a full name, etc., especially when you're just trying to sign up for an application. But this can be something you do as a next step once you are signed into the application. So in my mind, what we can do is inside the header, we can just have a tab that goes to your profile where you're then able to edit this information. So you can then change your full name, you can change your username, and you can change the bio as well. So let's work with cursor to begin implementing this functionality. Heading back into cursor, let's just respond to them. We'll say, we see that once we sign up a user, the profile is created in the backend Supabase, but the fields are pre-populated. We want a way to fill out our bio, full name, etc. Could we add a profile page to edit our details and have the header link to this once we sign in? So this way users will now be able to edit their full names as well as all their other details for their profile. So now it's gone ahead and implementing first a profile link to the header so that once we sign in, we're able to click into our profile. And then in the profile page, we're able to edit all the details so that our table in the backend will also update accordingly. And then once again, we have a profile table, but for the actual form, this will be reusable. So that's why we're again creating a public profile form component. And then let's accept all. This looks good on my end. Great. And then now let's go ahead and test our application one last time. Okay, so heading back into our application, let's first try creating a fresh account. So right now we have only one profile inside our table editor. And I would recommend just going back and forth between Supabase and your application just to make sure everything is updating in real time. So again, once we sign up a user, all this should pre-populate with our initial details. So let's do test user 10 just to start. So click sign up and we'll do test user 10 at, or maybe we've already done test user 10. So let's do test user 11 at gmail.com, test user 11. Let's click sign up. And we can see that we're taken to the dashboard, but now once we actually sign in, we have the ability to go to our profile. So let's first make sure that the header navigation link works. But before we go to the profile, just to confirm that everything is updated, we have a test user 11 right here. So like I mentioned, this just pre-populates with our initial details. So this is our full name, created at an email, and then the bio is null because there's no way to implement a bio inside that initial sign up. So now heading back into our site, let's go to the profile. And from here, we should be able to change our details. So for our username, we can keep this to be the same. But for our full name, let's change this to John Smith. And for the bio, it should say, I am John Smith, and click Save Profile. It says profile is updated successfully. And just as a final check to make sure this works, heading back into here, let's update our database. And let's see if the new details are populated. Perfect. So now for test user 11, which is still the username, our full name is now John Smith. These are not changed, so our created at is exactly the same, but now our updated at actually added time to it because we updated the name to John Smith. The email stays the same, but now our bio also says I am John Smith. So this means that our profile is now working perfectly to be able to edit our details once we actually sign into the platform. And then to sign out, we can just click dashboard first to go to the dashboard, make sure that works. Profile, it has all of our new details. And then to sign out, you can just simply click sign out. Perfect. And it takes us to the main landing page now. And then now that our profiles are completely finished, we can let cursor know by saying our profiles are now implemented. We see the updates within our Supabase database. Now let's begin working on implementing recipes into our app. And then we can also ask AI what they recommend in terms of workflows. We can say, can you recommend the workflow for implementing recipes? So creating new recipes, viewing all the recipes created from others in the dashboard, etc. And then we can kind of work with Claude here to just provide a path forward. So let's wait for a response. And we can see the recommended workflow here is to first create recipes. So this is implementing the add new recipe button to the dashboard so that users can submit their own recipes. Next is showing a list of all the recipes inside the dashboard. And then lastly is kind of like a recipes detail page, which as we can see from this root will be a dynamic page with this bracketed ID, which again is what we learned inside our fundamentals. So with our fundamentals, we kind of understand everything that's really happening here. So the first thing is to start with the recipe creation flow. So all we want to do is update the dashboard button so that it now links to a recipe's new form. They're creating the recipe's new form here. And let's accept all. So reading this, would you like me to continue with implementation? Start with the recipe creation form, update the dashboard. So let's first say start with the recipe creation form, just to make sure. Great. And then now let's have them provide all of the essential details. So now they're creating the recipe page. And I haven't accepted any of these changes yet because, again, we don't have anything as of now. We already have the recipes form component. Oh, so I guess they are accepted. Let me just accept this just to make sure. Dashboard button, recipe form. We already have the recipes form component created. So next would be to update the recipe type to match our form data. Now this is important because we need to make sure all of this does match what we have inside our Supabase. So let me just take a second to make sure that this is all accurate. So I just checked everything through, and the only change inside this database types is that, let's first accept this. The only change is that the cooking time should be an integer. So we can say in database types, cooking time should be an integer. So let's now wait for them to update this inside our file. So we can say that cooking time is now set to be number. Okay, so I see what's happening here. Rather than it setting it to be an integer, it seems like number is being treated as an integer already. So let's just undo this change since we want this to be nullable. And then below this, we can see that cooking time should be fine here. Let's update the recipe form as a required integer. Let's accept this. And we'll reject this change since the only thing that's really changing is this null value. So now let's test out our application. Once again, we'll log back into our profile. So we'll do test user11@gmail.com, test user11, sign in. We're taken to the dashboard, as we can see here, just to make sure everything is still working and not broken. This goes to the dashboard. This goes to our profile, where once again, our details are saved. So it's John Smith, I am John Smith. Let's head back to our dashboard and let's add a recipe. Great, so now this provides the new form component we just created. Now for this recipe, we can do something simple like scrambled eggs, 10-minute easy scrambled eggs recipe. And then for the ingredients, let's just add a few. So we can say 2 eggs. We can say butter, salt, and pepper. And then for the instructions, let's just do this step by step. So first, crack eggs. Next is whisk. Next is pour eggs, salt and pepper. And then lastly, we can say cook. For our cooking time, let's do 10. Difficulty, we can set this to be easy. And then category, we can say this is a breakfast. So let's click create recipe. And awesome, we now have this recipe created. So this is called scrambled eggs, 10-minute easy scrambled eggs recipe for breakfast, 10 minutes easy, perfect. So this is the title of our recipe. This is the description. This is what kind of category this recipe should be. And then lastly, we have the time and how difficult the recipe is. So next up, after we've done this, is to actually create the recipe's detail page so that we're able to click into the recipes to see the full details of the recipe. So right now we kind of just see a preview, but we want to be able to click into the recipe to actually get the instructions and the step-by-step guide on how to make these scrambled eggs. So now that new recipes work, we can say to cursor, we just created a new recipe and confirming that the form works. We also see the new recipe on the dashboard. Let's now implement a recipe's detail page like you mentioned. And just to make sure this was the next step, we can head back into the steps. So next, first we had recipe creation. This all works. Next is recipe list / dashboard. This all works. Next is single recipe view. So we'll do in parentheses, single recipe view. Great. And let's now wait for some more code to implement. Perfect. So now they're going to create a recipes detail page. So let's wait for this to generate and we can take a brief look at what the code looks like. Next, we can see we're updating the recipe card component to update to this. So this creates a dynamic route for each recipe. So heading over into app, recipes, and we can see this is the dynamic route now. So let's first accept these changes. And then we can say that there are some errors. So inside page.tsx for the recipes route, there are some ESL and errors. And let's have the AI just clean up this page a bit. It seems like these are the TypeScript errors like I mentioned, so you just want to make sure that everything is safely typed. So let's see if this fixes the main sections. Great. And the reason why I'm ignoring this page.tsx file is because this is actually correct. So we are supposed to import this profile form components. Sometimes, so as you can see here, we have components, profile form. It's importing the header correctly. This profile form is also here, but sometimes cursor just bugs out a little bit. So you can safely ignore this change, especially if you're able to actually go to the profile form. So I wouldn't worry too much about that. And then moving on here, let's now test out our application. So as a final check, we'll do npm run dev to restart our development server. And let's now see how everything works. And then just as a final check, just to show you what I did, I first tested it on the back end, but it seemed like there was showing up a 404 error when we pulled up the recipes. So I just literally copy and pasted the Supabase error here, which we couldn't find a relation between recipes and profile. And this was because, again, we joined it using a foreign key with the user ID. And what they did was essentially simplify our setup inside the query. So inside this page.tsx file, they just simplified everything. So that just kind of shows that when you're working with AI and you copy and paste the error, most of the times, if you just simplify the request a bit, it'll eventually fix everything. So from here, let's now try out this new recipe sharing platform. So on this here, I'm back to our main dashboard. We can do sign out just to show you the full workflow of how everything works. So let's log in to testuser11@gmail.com, testuser11. Let's sign in. We're taken to the dashboard. And then now let's go into the scrambled eggs detail page. And as we can see, it now takes us to the full detail page. And we can see that John Smith is the one that created this recipe. So after this, we should add in functionality that only John Smith is able to edit or delete this recipe and no one else. So from this, we can see that everything does work. Heading back to our dashboard, let's again click into this. And the reason why there was an error initially was because of this foreign ID join. So what we were doing is linking the profile of John Smith to this recipe. So that's what was causing errors in the cursor terminal. So to fix this, you would just simply copy and paste the exact error message like I did within cursor here, the Supabase error, and it should automatically fix your application for you. So now to round out this profile detail page, we'll just simply tell cursor the profile detail page works. We can see the profile that created the recipe as well. And we should call this recipe detail page. And then for this, we just want to add some functionality so that the creator of the recipe can edit or delete the recipe inside the detail page. And this allows people to be able to change the recipes around or delete it. But again, we only want the original user that created the recipe to be able to do this functionality. So now we're going to add action buttons to the recipe detail page. Great, it's just importing recipe actions. This is the actual component, the recipe actions component below this here. Now let's wait for this to load, head back into our files, and then updating the recipe form to handle creation and editing. So let's wait for all these changes to begin to implement. And let's do this one by one. So let's just first read how everything is working. We're importing recipe actions. This is calling on by setting the current user. This is the actual recipe actions component. This is for editing. We'll create a new route and reuse the recipe form component with modifications. So that means we'll be using the original recipe form component to edit the recipe. And then lastly, recipe form will handle both creation and editing, just like what I mentioned. So let's accept all and then begin fixing all of the syntax errors. So going one by one inside this recipe's form, we can say there are a few errors in this file. Please fix to be in line with NextJS. Now let's have the AI update all of these new recipes. So let's accept these changes and see what else is causing issues around here. So we can see that recipe ingredients and recipe instructions still have errors attached in that same file. And we can see that some of the errors are just due to undefined arrays. And arrays are just another data type that allows you to store multiple forms of data inside one array that you can call on. So let's accept this. And then we can see if there's any remaining errors inside this file. And we can do a dive into this file in more detail again. So we can see the first is the description. Second is cooking time, and the third is difficulty. You can see that there are still 3 errors in the value of cooking time, difficulty, and description. And again, we can see it's just to handle potentially undefined values. So let's wait for this to load. Great. And then lastly, this we can ignore like I mentioned, but for our recipes detail page, let's see where there's an error. Components recipe actions. So let's make sure that this is actually here. So we do have recipe actions as a component. So there shouldn't be an error technically. So let's just now run the application to make sure that everything does work. And we can report back with cursor with next steps. Okay, so heading into our recipe share app, let's log in as test user 11 because again, he was the one that created that scrambled eggs recipe. So let's log in. Wait for a sec. Perfect. We'll do test user 11 at gmail.com. Test user 11 signed in. Take into the dashboard and let's click into this. And we should have the ability to now perfect. We have the ability to edit or delete the recipe. So let's just try to edit the recipe first. Click edit. And instead of scrambled eggs, let's say scrambled eggs new. Let's do 4 eggs. Say no butter, more salt and pepper. New. Let's just do new for those 2. Change the cooking time to be 5 minutes. Difficulty, let's do medium. Breakfast still. Save, and we can see that all this information is now saved. So it says scrambled eggs new 10-minute easy scrambled eggs recipe. 4 eggs now, no butter, more salt and pepper. We have the new instructions here as well. And it's still by John Smith. So everything looks good. And the difficulty is now medium. So let's head back into the dashboard. And just to do a final check, let's first make sure that other users can't actually edit this recipe. So let's sign out and then sign in as test user 8. Test user 8. Maybe this wasn't a profile, so let me just sign up a new one. I don't recall all the test users we used. We'll do test user 14 at gmail.com. Test user 14. Let's sign them up. Great. So now for our profile, let's call this Jane Doe. I am Jane Doe. So let's remember that test user 11 and 14 are the 2 to save. So let's go back to the dashboard. And as we can see, because we're not logged in as test user 11, we're not able to edit or delete the scrambled eggs recipe. All we can do is view it. So now heading back into the dashboard, let's add a new recipe, but this time as test user 14. So let's add this recipe. We'll do test user 14's famous fried chicken. Good fried chicken. Ingredients. Fried chicken. Instructions. Cook chicken. And serve. Cooking time, let's do 50 minutes. It'll be hard to make fried chicken, and this will be a lunch food. Let's create this recipe. We can see this is test user 14's famous fried chicken. And then we can edit this. So let's call this amazingly good fried chicken, just to make sure that editing works once again. Amazingly good fried chicken, perfect. Now let's sign out as test user 14. Sign in as test user 11. So sign in here, and we can see this is test user 14's famous fried chicken. We're not able to edit or delete. We see that it's created by Jane Doe, which is the name that we set. But if we go to our scrambled eggs recipe, we are able to edit and delete. So now let's delete the scrambled eggs, delete the recipe. And it's completely gone from our application just like that. And now just to do one final test, let's sign out, sign back in as test user 14 at gmail.com and set the password. And we have the deleted recipe here. So we saw it when we were previously signed in, then we signed in as a new user, deleted that recipe, signed in as this user once again. So this dashboard is updating in real time. And then finally, we have test user 14, which is our profile right now, Jane Doe. And we're able to either edit or delete this recipe that we created. So this just basically shows you all the core fundamentals of creating a CRUD app. And as you can see, because this is linked to the database within Supabase, which we can also see here, everything is being updated in real time. So now within our tables, in our table editor or database, I should say, let's go to our tables and let's go to recipes. So for recipes, we only have one recipe because as we're updating and deleting the documents, it's immediately deleting from here. So now we only have one recipe, which is test user 14's famous fried chicken. We can see the description is automatically updated, amazingly good fried chicken. So if we wanted to, right now we're test user 14, let's just add a new one, Supabase test, put in a bunch of gibberish. Let's create this recipe. All right, this is Supabase test. So now if we go to the recipe sharing platform and refresh this, we can see that we now have two recipes. So now the new recipe we just created called Supabase test is right here in the cooking time 4501. So this will all update in real time. So rather than Supabase test, let's change this to be new Supabase test. Save this recipe, head back into our data table. And now this says new Supabase test. And then just as a final check, let's delete this recipe, head back into our data table, refresh once more, and we only have one recipe now. So this is how Supabase is working with your application. It's all interconnected, and this is happening in real time. And this is basically the crux of any application that has users that can interact with one another. Now let's begin cleaning up our app a bit and just making the user experience better. So the first two features that I think we should integrate is first a search function so that users can be able to search through recipes. So let's say, please implement this search function for our recipes dashboard. Let's now wait for Cursor to provide the new updated code. So they're gonna add a search bar and basic filtering. Now we obviously only have one recipe currently on the web app, so I'll make some more just in the backend, just so you don't have to sit through a few minutes or 30 minutes of me just adding in physical data to the data table, just so you can see how everything looks like as an end product when users do want to be able to search through the products. So now to test our application, let's now log in as test user 14. So I've added in a few recipes just to show you what everything looks like with multiple recipes inside the dashboard. So we'll do test user 14 at gmail.com. Test user 14. Let's sign in. And then as you can see, I've added in 6 recipes. Now what this search function will do is allow us to sift through all of the different recipes inside our app. So for example, if we only wanted to look at steak, we can type in steak, click search, and only the ribeye steak shows up. So now let's head back, delete all of the entrants, perfect. And then now we have categories that we can filter by as well. So these two are the filters. We can select either lunch, breakfast, or dinner. So as you can see here in this category, the lunch is bacon, mac and cheese, as well as famous fried chicken. So if we select lunch as a category, it only shows bacon, mac and cheese, famous fried chicken, and then also shrimp fried rice, which I didn't see. Next is breakfast, which is only an omelet. And then after that is dinner, which should be the ribeye steak, as well as the enchiladas. Perfect. So now let's do all categories. And then we can also sort this by difficulty. So all the easy recipes are the ribeye steak and the shrimp fried rice. The medium ones are the bacon, mac and cheese, and enchilada. And then the difficult recipes, or hard, I should say, is the egg omelet and famous fried chicken. So this just shows you how all the search functionality and filtering functionality works within our application. Now, the next thing we want to implement just for better user experience for people on our app is something called loading states. And with loading states, users will then be able to know when something is loading on the web page so they don't spam a certain button or that they think your web app is broken. So what I mean by this is that if we were to open up any of our recipes, so let's click into bacon, mac and cheese, it's completely blank for a second and then the detail page shows up. So what we want to do is show that something is loading, and typically web apps do this by having a skeleton. So within the skeleton, it essentially suspends your page so that it's kind of like a grayed out shell of what the page is supposed to look like, and it'll like pulsate between light and dark gray until the page actually shows up. So right now, when we navigate through our site, so let's go to the profile. Again, you click profile, completely blank for a bit, and then it just shows you the profile. It's just very jagged and sudden. So we want this to be a bit more smooth of an experience. Again, if we were to add a recipe, again, it's just very instant, but also there's no loading animation to let you know that something is loading. So what we can do is head over into cursor, and let's just go ahead and say that we want to add loading states to the pages of our web app for better user experience. And then within here, we just want to say that for the loading states, let's use basic suspense loading state. Great. And then now, just to make sure that everything else is fine, we can say we're also using a skeleton component. So like I mentioned, what this basic suspense loading and skeleton component does is show you an outline of the page, kind of like pulsating before the page actually loads. So let's go type this in. Let's wait for this to load. And you would generally want to do this for all pages of your web app. This is just for best practices so that users do know that your application is loading whenever they click on any button inside your application. Plus, it just makes it a bit easier to navigate through all the different pages, especially as your app grows in size. So now let's wait. Great. Let's accept these changes. And let's just head over through our specific pages to see what these errors are. Again, this seems to be a bug because recipe actions does work, so we can ignore this safely. For our profile, again, this is a bug because we're able to edit our profile form. So we'll collapse those two. Now for loading, we can see that skeleton as well as the search bar is grayed out. This one we can ignore because we have a component search bar right here. So let's just work on this loading.tsx file. And this seems to just be a syntax error. So we can say that we see an error in loading.tsx for lines 11 and 12 skeleton. And let's have cursor fix this issue. As you can see, we need to import the skeleton component into the dashboard loading file. So we're importing skeleton from components UI skeleton. Great. And we can see they created this new file called skeleton as well. So let's accept these changes. And then now let's head back into our web page to see how everything looks. So as you can see there, I don't know if you caught that, that was very glimpse, but there was a skeleton that was loading. So let's click into bacon, mac and cheese, make sure not to blink, and you can see the loading animations. Okay, let's head back. And then let's go to our profile. So as you can see there, that was a skeleton animation. Head back home. And then we can add a recipe. That was instantaneous, so it's a bit hard to tell. But this is just kind of like a best practice. So let me just show you what the profile looks like once again. If we click profile, it has the skeleton loading before the actual profile shows up. So again, heading back into the dashboard, we can see between profile, there's a loading, dashboard, there's also loading, add recipe is instant. So it's a bit harder to tell. But all these loading states do is let the user know on the other side that something is loading in your application. And it just makes for a more familiar experience, since this is what most applications utilize when you're traversing through different pages of the web app. Now that we have the core functionality built out for this recipe platform, let's begin incorporating some basic social features. So the two that I'm thinking of is the likes as well as comments, so that users can either like other people's recipes and they can also comment on other people's recipes. So to start, we'll first need to create additional data tables within Supabase. So we'll need to create first the likes data table, and then after that, we'll need a comments data table, because again, we're going to be getting this data and we're going to be adding this data to the data table once users kind of interact with our application. So let's take this step by step as we would normally do within Cursor. So we can say, let's begin implementing the likes and comment social features. Let's do this step by step. So first, provide the SQL commands. And recall again, these commands will just essentially help us create these tables within the Supabase dashboard. So let's wait for this to load. Great. So now Cursor has provided us with the SQL commands to create the data tables for likes as well as comments. So just remember again, anytime you're adding another form of data within your application, so this time we have recipes and profiles, but if you wanted to add likes and comments, these are always going to be individual data tables. So always be clear with the AI and have them create new data tables for you through the use of these SQL codes. So what we can do now is first create the likes table, and let's just do a quick check to make sure everything looks good. So we're going to have an ID for likes. What this means is that each individual like will have its own unique identifier, and this will be the primary key. Next, we'll have user. So each like will be attached to a user, and this will be a foreign key to auth users. So again, this is what we did before. This means that we'll be able to see who actually liked the recipe and tie that like back to the user. After that, we have the recipe that's being liked, because again, this is just the likes table. We don't know what's being liked. So this is why the recipe now references what we have in the recipes data table. And then finally, we have a created at time, and then the unique user ID and recipe ID. So let's first copy over this create likes table and then head back into Supabase. So we can go here, and then we can go to the SQL editor, and let's run this first query. So we can see success, no rows returned. So now if we head back into our table editor, or better yet, our database, inside our schema visualizer, let's clean this up a bit. So we have our profiles data table, which was always here. And we now have a likes data table. And this likes now connects our auth user's ID to the recipe ID. Or our auth user's ID connects to the user ID, and the recipe ID now connects to the recipe here. So you can kind of see the flow in which the likes is essentially working. And I don't believe we need to connect the likes to the profile, because again, the likes is already connecting to the authenticated user, and the profile is being connected to the authenticated user here as well. So now that that looks good, let's head back into Cursor over the comments table. So let's copy this SQL command again. and then head back into Supabase. Let's go to the SQL editor, delete this, and then run this query. So this will create the table for comments. Let's run this. And it says syntax error at or near it should be C. Seems like that didn't copy over. Let's run this. Perfect. Success, no rows returned. Let's head back into cursor and then enable RLS for likes and comments. So we'll just do this one at a time. Let's head back to Supabase, delete this, run this. Perfect. And again, we're just running everything one by one to make sure that there's no errors in syntax like we just saw earlier because I forgot to copy over the C in create. Heading back into SQL, we'll run this. Success. Back to cursor. Now these are all the policies for likes. So let's do this one at a time. And I will just do this off screen so you don't have to brave with me through all of these. So like I mentioned, I'll just copy these over one by one and run these one by one to make sure there's no errors in this section. So I'll see you once all of these SQL commands are copied into Supabase. Great, so now I've gone ahead and copied and pasted all of the SQL commands. And then we can say we have created all the SQL commands. Let's proceed with next steps so that they can begin working on our actual code base to implement these new data tables. So let's first see what cursor recommends. So the next step is to update our TypeScript types to include the new likes and comments tables. So let's first let this load. I'll collapse the terminal for the time being. And let's go to our database data types, and we can read all the changes here. So what they're doing is just adding in new types. So we have a type for like with ID, user ID, recipe ID created at. So these are the 4 fields. That looks good. Now for the comment, we have the ID, user ID, recipe ID, the actual content, which is the comment, when it was created, when it was updated, and then it'll export all of this information. So now this sets up our type system to handle basic like and comment data. It joined the queries together with profile information. So now let's go ahead and proceed with being able to create the UI components to like and comment on recipes. So let's proceed here. And we'll say, yes, let's do that. And again, by taking this one step at a time, we're able to see if there's ever any issues within our files. So now let's wait for this to load. First, we're creating a like button component. All this is doing is creating a button that allows us to like a recipe. Next is the comments component, which again is just to add a comment. And then because these are components, we can reuse these. So now let's wait for this. And then now that these components are created, what we want to do is then integrate these components into our recipe detail page. So let's accept this and then say, yes, help us integrate the components. And then we can worry about this error after. It should be a syntax error as an easy fix. But let's see what the issue is. It's on the comment item. Great, so let's first import the comment item. Great. And then importing the likes and comments components. So again, all it's doing, just so we're aware, is creating the individual reusable components and just importing everything into our files. So now let's accept all, and let's just read these changes. So added imports for like and comment, updated the query to fetch likes and comments with profile data. This is important to connect Supabase to our application. Added data transformation, added like buttons and comments, conditional rendering, proper sorting. And again, if I was working on this alone, it's a little bit better just to understand all of these changes, but this video is getting a bit long. And I just want to make sure that we're able to see the final product and showcase how good AI is at generating code. So I'll just accept these changes for now and we can debug as we go along. So now let's try to see if this all works. So now let's go ahead and test our platform. So if we go into any of our recipe detail pages, so bacon, mac and cheese, We can see that we now have a like functionality as well as comments. So let's click like. We can see the like has been updated, and then let's post the comment. So let's say test. We can see that no comments are actually saved. So let's see if this like saved as well. First, head back to the dashboard, go here. We can see the like didn't save either. So what we can do is now head over into Supabase and let's refresh our data tables, and we can see if the data was saved or not. So we can see that for likes and comments, there's actually no rows being added. So what this means for us with debugging is that this data isn't being saved to Supabase. So there is an issue somewhere. So what we can do is inspect this page, and let's first click like, and we can see that we're getting a 403 forbidden error. So let's go ahead and just copy and paste this error into Cursor and just work with it to make sure that they can debug this issue so that our data is saved to the database. So after going back and forth with Cursor, all I did was copy and paste the console browser errors as well as the terminal errors. And all they did was update the components for us just to make sure that the parameters could pass. But now if we go into any of the recent recipes, so bacon, mac and cheese, we're now able to like and comment. So if I did test 1 comment, let's head over into our Supabase Datatable, and we can see that we now have a like, which is that like we just did, and then 2 comments. So I tested this out with one saying test, and another one will say test 1, which we just did. So let's go ahead and view this table. You can see we have one that just says test, and then the other one that says test 1. So everything looks good. Now what we can do is head back into Cursor. As you can see, this is what we changed. Said I already have RLS in the screenshot. All I did was copy and paste this error, post 403 forbidden. So what they did was change the like button component for this, as well as the comment section, just to await the data. Again, this is from the API routes that we learned. They're just awaiting and fetching the data properly. And from here, we can say everything now works and is being saved to the database. Can you now display comments in the recipes detail page? So now we can work with Cursor to make sure that comments are now being displayed as well. So let's wait for this to load. And we can see that they're just always showing the comment section in the heading, only show with form for logged in users. That's fine for RLS policies, showing read-only comments for non-logged in users, added a message when there are no comments, proper data formatting, great. And honestly, this read-only comments for not logged in users isn't really relevant because non-logged in users can't even access the dashboard. So we don't need to be too concerned about those rules for the time being. But obviously, if you're building out your application differently, then you do want to make sure that logged in and non-logged in users have different parameters. But let's head back into our project and go to recipe share. Okay, let's click into the bacon mac and cheese. Let's do display test. Let's post this comment. We can see it says no comments yet. Let's refresh this. So we can see it says no comments yet, but let's make sure that the comments are being saved. So let's refresh this data table. And we can see that we have a display test. The only issue is that the comments are not being displayed. So let's head back to Cursor and we can say, I just made another comment, but the UI still says no comments. I have confirmed the comment is saved in our Supabase database. And let's wait for this debug fix as well. So now it's removing the condition to show the no comments. Let's click accept here. Just make sure everything's fine. Let's now head back over into our platform. We'll reload this. Go to bacon mac and cheese. Post comment. Still says no comment. Head back into cursor. Say comments are still not being displayed. And great, now it's adding some proper error logging. So from here, we can receive the proper error messages to copy and paste. This way, you're kind of getting one step closer to debugging the issue. So let's first accept these. We're adding debug logging. So once again, we can see where the data is missing. Let's accept this. And then let's open up our application one last time. But this time, we just want to have the console opened just to see where the error is occurring. So from here, you can click inspect and it'll open up a console log on your other window. So we can click into bacon mac and cheese, scroll down. You can see that there's no comment here and we're getting a server error. So I'll just copy this error into cursor. So now what I've done is copied and pasted the error into cursor, and this file should now be updated with the latest versions of the likes as well as the comments component. So now heading back into our recipe sharing platform, let's now test out this workflow from the beginning. So what we can first do is sign up for a user, and let's first make sure that our app is indeed running. We'll do npm run dev. Great, so let's head back, reload the site. So like I mentioned, we first want to sign up a blank user just to show you the entire workflow. So this is to create a new account. We'll do final test user 1 at gmail.com and the password will be final test user. Let's sign in here. Great, so now we can see all of the different types of recipes that users have uploaded to the dashboard. And inside the bacon mac and cheese, we'll click into this here. We can see that there's been 4 likes. So I was just testing out the likes in the back end. And we also have all the comments that we previously made before. Now, one important thing to note is that inside our profile, let's first update our details. Rather than calling us final test user 1, we can say Alex Adams, just as a placeholder name. For the bio, we'll say I am Alex Adams. Let's save this profile. And then heading back over into the dashboard, let's test this out by first liking this new recipe. So click a like here. We can see this has been updated to 5 likes for bacon mac and cheese. And then to test this out inside our Supabase backend, if we go to the likes, we can see that we now have 5 likes here. And let's edit this table. Or let's expand the table, but rather than that, we can just follow this ID. So for this recipe ID, it should now go to bacon mac and cheese. Perfect. So again, what we're doing here is that we can see all of the recipe IDs are for the same exact recipe ID. So if we follow one, we're essentially following the same recipe ID, and all of these go to the bacon mac and cheese, meaning that there's 1, 2, 3, 4, 5 likes for bacon mac and cheese. So this means that all of these likes are being saved properly, 5 here. Now what we can do is add a comment. So I will say this is a test comment for Supabase. Let's post this comment and then let's force a refresh here just in case it doesn't refresh live. And we see Alex Adams posted a comment that says this is a test comment for Supabase. And then if we go over to Supabase and go to the comments, we should now see this as well. Let's just refresh the page one last time. And we can say we see this is a test comment for Supabase. Perfect. Now, one important thing that we also want to test out here is that the original user of this recipe, so Jane Doe, the one that created this bacon mac and cheese recipe, should be the one that's able to delete comments, but no one else. So as you can see, anyone can post a comment. We posted one right here, but now let's go ahead and sign out of this user and sign in as Jane Doe. Now, before we continue to sign in as Jane Doe, let me just do a quick refresher to see which user is actually Jane Doe. We have one called test user 14. So now heading back, we can log in as test user 14. at gmail.com, and the password will also be testuser14. Let's sign in here. And let's go to the bacon mac and cheese. Great, so we have the ability to edit or delete the bacon mac and cheese. We're showing the 5 likes, and then now if we scroll down to the comments, we're able to delete all of these comments because once again, we are the original owner of this recipe. So this means that we have the full functionality working inside our application. This is very exciting because this is essentially the basic crux of what you need to build any type of CRUD application. Obviously, you'll have more complex functions on top of this as you build more things out. For example, you could have a full social platform here. You can also add image uploads, file uploads, even conversations between users, leaderboard rankings, for example. But this right here is just the main structure that you really need to set everything in motion. And this covers most of the concepts to building a successful SaaS web app. Now, as a final feature on our application, let's add a saved tab so that every single recipe that you physically like on your user profile should show up in your saved recipes. So for this, we can first go to cursor and say we want to add a saved page that shows all the recipes you've liked on your profile. And this will essentially incorporate all of the features that we've added in before. So the data table already has users attached to the likes. So this should be fairly easy to create. All we need is a new page for the saved recipes, as well as possibly a component to show all the different recipes. So here, all we're doing is adding a loading state, which we have across the entire app already, as well as a header component to add a link to the saved recipes. And the middleware essentially acts as the router between your front end and back end. So let's accept all of these. And let's see if there's an error here. It's at our page.tsx. Let's first accept this file. And then we can fix this in Composer as well. And what I did for the remaining page.tsx errors, like I mentioned, they weren't actually errors. It was just a bug in the IDE. So what I did is just restarted cursor so that it no longer showed import errors for all of those messages. And then we can see this is now fixing the type conversions. So let's wait for this to load. So now heading back into our application, you can see that within the header, we now have a tab for saved recipes. So if we click on this, we have the bacon mac and cheese that we just liked. So this just means that all of our liked recipes will be shown up inside the section. And just as a further clarification, we're right now Jane Doe. So let's like another recipe. Let's like this famous fried chicken. We'll give this a like. Now, if we go to saved recipes, we have famous fried chicken as well as bacon mac and cheese. Just to sign in with a separate user, we'll do final test1 at gmail.com. Final test1. These are invalid login credentials. So let me just create a new user. New user at gmail.com. New user. Great. And then let's now like this bacon mac and cheese. Go to saved recipes. And then we have this as a saved recipe. So now if we head back and like enchiladas, we should now have this as a saved recipe as well. Perfect. Let's now deploy our application to bring it live completely using Vercel. So what you first want to do is do a final commit, which if you recall from our previous lessons is just essentially a checkpoint for you to save your project. And in our case here, we have one called final, and this is our final version of the app thus far. And then once you commit the app, you'll have an option to click publish online. So by publishing online, it'll send your entire project, so all your code here, into your GitHub account. You just have to make sure that everything is linked from GitHub to Cursor. So once you do link your GitHub account to Cursor, you can publish. And then on Google, what you want to do is head over to Vercel and then log into that same exact GitHub account. So for myself here, I have the recipe sharing platform. So it's import Git repository. All you want to do is find your Git project that you imported. So once again, just publish this to your GitHub account, head to vercel.com, log in into your GitHub account, and then import the project. So from here, we can call this recipe sharing platform. We can keep this to be the same name, and then let's click deploy and wait for this to load. Perfect. So now it just takes a little bit to build the logs, show the summary, and then assign custom domains. But for our case, we can just use the domain that's given to us through Vercel so that we don't have to pay for our own domain. But obviously, if you want to build your own app and have real users on there, you need to first buy a domain either from GoDaddy or Namecheap and then paste in your DNS credentials to this here so that your production application will be shown on that specific domain. Now our app is finally deployed on Vercel, but right now if we visit the application, we can see that there's a server-side error. Now the reason for this is because the URL, if you recall from when we worked on Supabase, we need to update this site URL to be the latest. So what we can do is just simply copy over this deployment URL. Let's paste it into Supabase and then have this load. And after updating the deployment URL, the second thing you'll need to add is your keys, because Vercel needs to know your .env file keys to be able to connect to Supabase. So what you want to do is head over into settings, and then in settings, go to environment variables. And here you can paste in your keys. So I'll do that now. Great, and then after pasting in your keys, all you want to do is redeploy here. And then right now we can revisit our domain, authenticating, and now we have our application live on the internet. So this is the URL for our application. We can sign up a new user. So let's just do verceltest@gmail.com. This will be verceltest. Sign them up. Perfect. And then now we have the same exact recipes that we created while on the localhost server. As you can see, the likes should be saved. 6 likes, we'll make it 7. The comments should be saved as well. And then if we go to our saved recipes, we now have that bacon mac and cheese we just liked. So as you can see, this is how easy it is to redeploy your app from a local host server to this actual online URL. And then obviously once you buy a domain, you can then change the domain here to be the domain that you want. So in our case, if our application here was called recipe share, then this would be recipeshare.io or recipeshare.com.